Welcome students. In this video, let us try to have a basic understanding of inverse trigonometric functions. The first question that we are going to deal with is, what are inverse trigonometric functions? In the previous module of functions, we have already seen what an inverse function is. So if f of x is a function, f inverse of x is a function which satisfies the condition f inverse of f of x is equal to x and f of f inverse x is equal to x. That is, so if f connects an element x in the domain to an element y in the codomain, f inverse is defined from the codomain of f to the domain of f, and it brings back y to x. This is the definition of inverse function. As the name suggests, inverse trigonometric functions are inverses of trigonometric functions. We know that you have 6 trigonometric functions: sin x, cos x, tan x, cot x, cosecant x, and secant x. So what we are going to learn are the inverses of these functions. So we usually denote it by sine inverse of x. Sine inverse of x is the inverse of sin x. Cos inverse x, this is not equal to 1 by sin x. This power minus 1 does not imply what it implies in the chapter of exponents. So usually in the chapter of exponents, a power minus 1 is 1 by a in the chapter of exponents. But in the chapter of functions, power minus 1 denotes the inverse function, not the reciprocal function. Similarly, you have functions tan inverse x, cot inverse x, cosecant inverse x, secant inverse x. These are the inverse functions to the trigonometric functions. Now, what is so special about inverse trigonometric functions? The specialty is that these inverse functions cannot be defined for complete function of sin x, because we have already seen that inverse functions exist only for bijective functions. Inverse will be defined only for 1, 1 onto functions. Now, are trigonometric functions 1, 1 onto? No, right? These trigonometric functions are periodic functions. Means a particular value goes on happening again and again after a certain interval. So, sin x, cos x, tan x, cot x, cosecant x, and secant x are not bijective functions. So to define the inverse, first we need to restrict the domain and the codomain so that the functions become bijective, and within that domain and range we'll have to define the inverse of the function. So we have already seen that a function can be made into a bijective function by appropriate restriction of domain and codomain. So for example, so if f of x is equal to sin x, if this function is defined from real numbers to real numbers, this is not a 1, 1 onto function. So first let us try to understand the domain restriction under which these functions become 1, 1 and onto. Let us first take the graphs of y is equal to sin x and y is equal to cos x. So this is f of x or y is equal to sin x is the graph, as you know, and the second is the graph of cos x. So if these functions are defined from real numbers to real numbers, obviously these are not one-one onto functions. So first, let us make this function into an onto function. So how do you make the functions into onto function? By appropriate restriction of codomain. We know that the range of sin x and cos x is minus 1 to 1. So I'll make the range equal to the codomain. So first I'll define these functions from real numbers to minus 1 to 1. So if I do this restriction of codomain, now the codomain is equal to the range of the function, hence this function has, both these functions have become onto functions. But if the domain is real numbers, the 1-1 nature is being not satisfied, because corresponding to a particular y, if you draw a horizontal line, it cuts the curve at many points. For a 1-1 function, it has to cut at 1 or 0 points. So first what we do is, we try to restrict the domain. So we have seen that there are different ways in which domain can be restricted. So what we are doing now is the standard restriction, which everyone will do. All the mathematicians have agreed upon. So the restriction for the function sin x is minus pi by 2 to pi by 2. So I'll restrict the domain to minus pi by 2 to pi by 2 and the codomain to minus 1 to 1. So within this domain and within this range minus 1 to 1, so you have only this part of the graph, this part of the graph. So this part of the graph is a 1-1 onto function, hence this is a bijective function. So only for this part of the graph we define the inverse function. So what is the restriction of domain? Minus pi by 2 to pi by 2. What is the restriction of range? Minus 1 to 1. So within this domain and codomain, the function sin x becomes a 1-1 onto function, and sine inverse of x is the inverse of this part of the function. Similarly, if you take the function cos x is also not 1-1 onto. So for this we restrict the domain and codomain like this. The domain is restricted to 0 to pi, because for cos x minus pi by 2 to pi by 2 does not work. So between minus pi by 2 to pi by 2, cos x is not 1-1. So we restrict the domain to 0 to pi. So we take this graph. We take this part of the graph from 0 to pi, from minus 1 to plus 1. So the domain is 0 to pi and the range is minus 1 to 1. So for different functions, you have different restrictions. For sine, minus pi by 2 to pi by 2 and minus 1 to 1. For cos, 0 to pi and minus 1 to 1. So let us look at the further restrictions for the other functions. So next, for the functions tan x, cot x, cosecant x, secant x, also we do appropriate restriction of domain and range. So for tan x, we take the domain from open minus pi by 2 to pi by 2. So tan x defined in open minus pi by 2 to pi by 2, and the range is from minus infinity to infinity. It is all real numbers. Similarly, for cot x, the restriction is between 0 to pi. So if you take one arm of cot x, it is both 1-1 and 1-2. So the restriction for cot x is from 0 to pi, open 0 to pi, because cot is not defined in 0 and pi, to all real numbers. and for the function cosecant x. So cosecant x is not defined where sine is equal to 0. So we take half arm here and half arm here. So we take these two arms, and with respect to these two arms, cosecant x is 1, 1 and odd. So the domain is minus pi by 2 to pi by 2, minus pi by 2 to pi by 2 closed except 0, because at 0 it is not defined, and the range is from minus infinity to minus 1, minus infinity to minus 1, union 1 comma infinity. So within this domain, minus pi by 2 to pi by 2 except 0, and codomain minus infinity to minus 1 and 1 to infinity. The function is bijective. For secant x, we take half of this arm and half of this arm. So the domain is closed at 0 to pi except pi by 2, and the range is again the same as cosecant. So these are the restrictions of the domain and range for the trigonometric functions under which the inverse can be defined. So the functions sine inverse, cos inverse, so on are inverses of the trigonometric functions only within those domains and codomains. So this is what you need to understand clearly. So what are the domains and ranges of inverse trigonometric functions? So if you take the inverse trigonometric function sine inverse x, what is the domain of this function and what is the range of this function? So if you look at the trigonometric functions like sine x or something, so if you take y is equal to sine x, this is a trigonometric function. It takes in the values of x, which are angles. That is, inside, if you take sine x as a machine, it takes in the values of angles and it gives you the values of trigonometric ratios. It takes in angles and gives out the values of trigonometric ratios. That is, it gives out some numbers. So if you put pi by 2 within the function sine, it gives out the value of 1. Sine pi by 2 is 1. So sine x trigonometric function takes in angles, gives out numbers. So these inverse functions takes in numbers and gives out angles. So what is the domain of sine inverse x? It takes in numbers between minus 1 and plus 1, and the range is minus pi by 2 to pi by 2. So you got this from the restricted domain and range of the original function. So what is the restricted domain and range of sine x over which inverse is defined? Domain is minus pi by 2 to pi by 2. Range is minus 1 to 1. So for the inverse function, domain and range gets reversed. Similarly, cos inverse x also takes in numbers between minus 1 and plus 1 and gives out angles between 0 to pi. Tan inverse x takes any number in the real numbers and gives out values from open minus pi by 2 to pi by 2. Cot inverse x takes in any real number, and gives out angles between open 0 to pi. Cosecant inverse and secant inverse takes in values from minus infinity to minus 1, union 1 to infinity, and gives out values between closed minus pi by 2 to pi by 2 except the angle 0. Angle 0 does not occur in the range of cosecant inverse x. This whatever number you put here, it will never give you 0 as the answer. Similarly, secant has a domain of minus infinity to minus 1, union 1 to infinity, and the range of 0 to pi except pi by 2. So these domains and ranges have to be carefully remembered. So the trick to remember is you have 3 of them whose ranges are related to minus pi by 2 to pi by 2, and 3 of them whose ranges are related to 0 to pi. So sine inverse, tan inverse and cosecant inverse. These ranges are related to minus pi by 2 to pi by 2. One is closed minus pi by 2 to pi by 2. One is open minus pi by 2 to pi by 2. One is closed minus pi by 2 to pi by 2 except 0. Similarly, cos inverse x, cot inverse x and secant inverse x. These 3 have ranges related to 0 to pi. So I hope you can remember this. Sine inverse, tan inverse, cosecant inverse. These 3 are more related to sine, because all of them, tan inverse is sine by cos. Sine is more prominent in tan. Cosecant is 1 by sine. It is related to sine. So sine, tan inverse and cosecant inverse have ranges related to minus pi by 2 to pi by 2. The remaining 3 have ranges related to 0 to pi. So once you understand this, now you need to understand how to find the inverse functional values for some certain values of x. So let us do that with help of examples. So let us take some very simple examples. So let us say that you are asked to find the sine inverse of the value half. So let us take certain examples. Sine inverse of root 3 by 2. Sine inverse of 1 by root 2. Sine inverse of 1. Sine inverse of minus 1. Sine inverse of minus 1 by 2. Sine inverse of minus root 3 by 2. So on, let us try to find these values. Now, what is the meaning of sine inverse of half? What is the meaning of sine inverse of half? So we have already seen that inverse functions take in numbers and gives out the values of angles. So sine inverse of half is some angle theta which belongs to the range of sine inverse. That is, if a number goes inside sine inverse function, this number has to belong to the domain of sine inverse. What is the domain of sine inverse? Minus 1 to 1. So you should make sure that the numbers which are going in are in between minus 1 and plus 1. So if the number is outside minus 1 and plus 1, sine inverse will not be defined. So half is in between minus 1 and plus 1. So it is okay. And what are the numbers that comes out? What are the angles that comes out of sine inverse? That is the range of sine inverse, which is minus pi by 2 to pi by 2. That means sine inverse of whatever number you have, you always get an answer in between minus pi by 2 to pi by 2. So now, once you understand this, sine inverse of half is an angle which belongs to minus pi by 2 to pi by 2. That is minus 90 degrees to plus 90 degrees. Such that if sine inverse goes onto that side, you get sine theta is equal to half. So if I ask you sine inverse of half, you need to give me some angle in between minus pi by 2 to pi by 2 whose sine is equal to half. So now just think about the values of sine theta. So for what value of theta is sine equal to half? Pi by 6, right? Pi by 6 or 30 degrees. And remember, sine theta will be half for many angles. in trigonometric equations, we have solved this equation. Sin theta is equal to half has a general solution of n pi plus minus 1 whole power n times pi by 6. This is a general solution. But the answer that we write here is that particular solution which lies in between minus 90 and plus 90 degrees. So sine inverse of root 3 by 2 correspond to which angle? Sine is root 3 by 2 correspond to 60 degrees, right? So the answer will be pi by 3 or 60 degrees. Sine inverse of 1 by root 2 correspond to which angle? Is sine equal to 1 by root 2, 45 degrees. The answer is pi by 4 or 45 degrees. Corresponding to which angle sine theta is equal to 1? Pi by 2 or 90 degrees. So this is how you find the values of sine inverse. Sine inverse of minus 1. So corresponding to which angle is the value of sine theta equal to minus 1? So if you draw the quadrant diagram for sine theta is positive in the first two quadrants, negative in the second two quadrants. And we are searching for an angle from minus pi by 2 to pi by 2. We are not searching for angle here. The answer is always from minus pi by 2 to pi by 2. Now, if you have a negative number inside sine inverse, you get an angle in the fourth quadrant. So sine inverse of minus 1 is minus pi by 2 or minus 90 degrees. Similarly, sine inverse of minus half. Where will sine be equal to minus half? According to the convention, you have to take the fourth quadrant angles. So minus pi by 6 or minus 30 degrees. Sine inverse of minus root 3 by 2 is minus pi by 3 or minus 60 degrees. So if you have a positive number inside sine inverse, you get an acute angle. If you have a negative number inside sine inverse, you have a negative angle. That is an angle in the fourth quadrant. Let us do the same analysis for cos inverse and see how the values change. Next, let us try to see how to find the values of cos inverse. Again, cos inverse is a function which takes in numbers between minus 1 and plus 1 and gives out angles between 0 and pi. So if you draw the quadrant diagram for cos is positive here, negative, negative, positive. And the range of cos inverse is 0 to pi. So the answers that you get here are some angles between 0 and pi. And if a positive number goes inside cos inverse, you get numbers in the first quadrant. If negative numbers go inside cos inverse, you get numbers in the second quadrant. That's the difference between sine inverse and cos inverse. For positive numbers, both sine inverse and cos inverse gives you angles in the first quadrant. But for negative numbers, cos inverse gives you angles in the second quadrant, sine inverse gives you angles in the fourth quadrant. What is cos inverse of 0? Cos inverse of 0 is some angle theta which belongs to 0 to pi such that cos theta is equal to 0. So for what value of theta cos is equal to 0? Pi by 2, right? So the answer here is pi by 2 or 90 degrees. Similarly, cos inverse of half. For what value of theta cos is half? 60 degrees. The answer is pi by 3. Cos inverse of 1 by root 2, pi by 4. Cos inverse of root 3 by 2, pi by 6. Cos inverse of 1. For what value of theta cos is 1? 0. Be clear about this. Cos 0 is 1, so cos inverse of 1 is 0. What is cos inverse of minus 1? So for what value of theta, the value of cos is minus 1. So the answer is pi, right? So we have to go to the second quadrant. Minus 1. So we have pi as the answer. Minus root 3 by 2. Minus root 3 by 2. So plus root 3 by 2 corresponds to pi by 6. So you have an allied angle here. Is pi minus pi by 6 is 5 pi by 6. Minus half. Correspond to half, you have 60 degrees. Correspond to minus half, you have an allied angle in the second quadrant. Pi minus pi by 3 is 2 pi by 3. So here also you have pi minus pi by 4 is 3 pi by 4. Next, let us go for the values of tan inverse. Next, tan inverse of certain numbers. So tan inverse takes in values which are real numbers and gives out values which are in between minus pi by 2 and plus pi by 2. So if you draw the quadrant diagram for tan, plus minus plus minus, and our range is in 4th and 1st quadrants from minus pi by 2 to pi by 2. That is, if a positive number goes inside tan inverse, the answers will be in the 1st quadrant. The angles that you get will be in the 1st quadrant. And if negative numbers goes inside tan inverse, the answers will be in the 4th quadrant. The answers will be angles in the 4th quadrant. So remember this. So tan inverse of 1, the question is correspond to what angle tan theta is 1? Pi by 4, right? Tan inverse of 0 correspond to what value? The value of tan is 0. 0. Root 3 pi by 3. 1 by root 3 pi by 6. Tan inverse of infinity. So usually this doesn't happen because infinity is not a number. But if the number inside this tends to infinity, the value of tan inverse of that number tends to pi by 2. Similarly, if you have a negative number, you get an allied position in the 4th quadrant. Tan inverse of minus 1 by root 3 is minus of pi by 6, the allied position. Tan inverse of minus root 3 is minus pi by 3. Tan inverse of minus infinity is tending to minus pi by 2. So I hope you're understanding how to find the values of inverse trigonometric ratios. We do the similar analysis for cot inverse, secant inverse as well as cosecant inverse. So to understand cot inverse, let us draw the quadrant diagram for cot inverse. So the quadrant diagram for cot inverse looks like this. So cot is positive here, negative here, positive here, negative here. And the range of cot inverse is from 0 to pi. So we draw this. So if you take positive numbers inside cot inverse, you get angles in the 1st quadrant. Cot inverse negative number, you get angle in the 2nd quadrant. So cot inverse of root 3. So for what value of theta is cot equal to root 3? Pi by 6. So this answer is pi by 6. Cot inverse of minus 1 by root 3. So you have a negative number here. So you go to angle in the 2nd quadrant. So first find the allied angle. It is, what is cot inverse of 1 by root 3? For what angle will cot theta be 1 by root 3? The answer is 60 degrees. That means correspond to 60 degrees, the value of cot is plus 1 by root 3. So if you want cot theta is equal to minus 1 by root 3, it happens in the allied position. So what is the allied position of pi by 3 in the 2nd quadrant? Pi minus pi by 3 is 2 pi by 3. Secant inverse of 2. Again, what is the quadrant diagram for secant inverse? So secant is positive here, negative here, negative here. And the range of secant inverse is 0 to pi. This is how you draw the diagram. Now, if positive numbers goes inside secant inverse, you get angles in the first quadrant. If negative numbers goes inside secant inverse, you get angles in the second quadrant. Secant inverse of 2. For what value of theta is secant equal to 2? Pi by 3. For what values of theta secant is minus 2 by root 3. Negative number, you want to go to the second quadrant. First find the allied position in the first quadrant. So for what value of theta, secant theta is 2 by root 3. If secant theta is 2 by root 3, cos theta has to be root 3 by 2, which implies theta is equal to pi by 6. So corresponding to pi by 6, secant theta is plus 2 by root 3. So correspond to what value will secant theta be minus 2 by root 3? Allied position. Pi by 6, the allied position is pi minus pi by 6. 5 pi by 6. Secant inverse of minus root 2 correspond to root 2, the angle is pi by 4. Correspond to minus root 2, angle is pi minus pi by 4. 3 pi by 4. Next, cosecant inverse, cosecant inverse, cosecant inverse. Same thing. What is the quadrant diagram for cosecant inverse? Plus, plus, minus, minus. And the range is minus pi by 2 to pi by 2 except 0. So what is cosecant inverse of root 2? First quadrant pi by 4. Cosecant inverse of minus 2. First find the allied position in the first quadrant. Cosecant is equal to 2 corresponds to pi by 6. So cosecant inverse of minus 2 is minus pi by 6. Minus 2 by root 3 correspond to 2 by root 3, we have pi by 3. Correspond to minus 2 by root 3, we have minus pi by 3. So I hope you are understanding how to get the values of inverse trigonometric ratios. Now, let us try to understand the graphs of inverse trigonometric functions. So to draw the graphs of inverse trigonometric functions, the simplest way is to draw a table of values. So if you are asked to find the graph of y is equal to sine inverse x, you want the graph of y is equal to sine inverse x. First what I'll do is, I'll take the coordinate system. First, what is the domain and range of sine inverse? The domain is minus 1 to 1 and the range is minus pi by 2 to pi by 2, right? You have already remembered this. That means the graph extends about x-axis from minus 1 to plus 1. And the graph extends along y-axis from minus pi by 2 to plus pi by 2. That is, if I draw a box like this, if I draw a box like this, the graph of y is equal to sine inverse x lies inside this box. So I hope you have understood until this point. Next, if positive numbers goes inside sine inverse, you get angles in the first quadrant, right? So 0 to pi by 2 corresponds to angles in the first quadrant. 0 to minus pi by 2 corresponds to angles in the fourth quadrant. So if positive numbers goes inside sine inverse, you get values of y in the first quadrant. That means the graph lies in this part, and if you take negative values inside sine inverse, the answers lies in the fourth quadrant. That means the graph of y is equal to sine inverse x lies in this part and this part. the graph does not go into these parts. And to get the shape of the graph, we'll try to draw a table correspond to x's and y's. So let us take some positive x's, let us take some negative x's. So corresponding to 0, value of sine inverse is 0. Correspond to half, value is pi by 6. Correspond to 1 by root 2, value is pi by 4. Root 3 by 2, pi by 3. 1 pi by 2, and you get the values in the fourth quadrant corresponds to negative values. It is minus 1 by 2, minus pi by 6, minus 1 by root 2, minus pi by 4, minus root 3 by 2, minus pi by 3, minus 1, minus pi by 2. So let us plot all these points and join them with a smooth curve. You should get the graph of sine inverse x. So 0, 0, that's 1 point. Half, pi by 6. So if this is pi by 2, you need to divide this into 3 parts. This is pi by 6, pi by 3. So half corresponds to pi by 6. Next, 1 by root 2, something like 0.7. So 1 by root 2 corresponds to pi by 4. Pi by 4 is somewhere in between them. Root 3 by 2, 0.8 something corresponds to pi by 3. 1 corresponds to pi by 2. So if you draw the graph, it looks like this. And you get a similar graph correspond to these values in this part. So you get a graph like this. So this is how the graph of sine inverse x looks like. The domain is minus 1 to 1 and the range is minus pi by 2 to pi by 2. It is an increasing function. Increasing function. Sin x is an increasing function. Sine inverse x is also an increasing function. Next, if you want to draw the graph of y is equal to cos inverse x. The domain is minus 1 to 1. The range is 0 to pi this time. So if you draw the graph extends from minus 1 to plus 1 and from 0 to pi. So this time the graph does not go below x-axis because the whole range is positive. Again, if you draw a small box like this, if you draw a box like this, the graph of y is equal to cos inverse x has to lie on this, in this box. And corresponding to positive values of x, the answers lies in the first quadrant. The range lies in the first quadrant. As you get a graph in this box, correspond to negative values of x. The answers are in the second quadrant. As you get a graph in this part. So you get graphs in these two boxes. So how does the graph look like? Cos inverse of 0 is pi by 2. Cos inverse of 1 is 0. Cos inverse of minus 1 is pi. So just with these three values. So you have a smooth curve joining these values. So how many different options do you have? You can directly join them. That's not the graph. You can join them like this, or you can join them like this. So what is the actual graph looks like? So how I usually remember is the graph of cos inverse x does not look like the graph of cos x. So if you take the graph of cos x, so it looks something like this. From 0 to pi, the graph of cos x looks something like this. So cos inverse x should not look like this. So it cannot go like this. The graph will look like this. So each time you cannot plot all the values. You cannot draw the table and always you have to get the graph. So if you want to draw the graph quickly, identify the domain and range, and then identify the boxes where the graph of cos inverse lie, and get some sample points, very easy sample points, and draw the graph. So you should remember that the graph of inverse function should not look like the original function. So this is how the graph of cos inverse x look like. So even if you draw the table and plot the points and join them with a smooth hand, you get the same graph. Next, let us try to draw the graphs of tan inverse and cot inverse. Y is equal to tan inverse x. So the domain is all real numbers and the range is minus pi by 2 to pi by 2. So if you take the graph, on the x-axis you have to consider the whole real numbers as the domain. And the range is from minus pi by 2 to plus pi by 2. It means if you draw horizontal lines like this, the graph has to lie within the space because the range is only in between minus pi by 2 and pi by 2. And you have an open minus pi by 2 to pi by 2. That means the graph has to asymptotically meet these two lines. Now, if x is positive, the values of angles are in the first quadrant. If x is negative, y is negative. So you have graph here and here. And what is the sample point? Tan inverse of 0 is 0. And it has to asymptotically meet this line and this line. So obviously it cannot go like this. It cannot go in the direction of tan x. So it has to go like this. There is no other option. So here also it has to go like this. Asymptotically it goes to minus pi by 2 and plus pi by 2. So this is how the graph of y is equal to tan inverse x look like. So if you take the graph of y is equal to cot inverse x, y is equal to cot inverse x. The domain is real numbers and the range is 0 to pi. This time. If you draw the graph, something like this, the domain is all real numbers, the range is 0 to pi. And you have a pi by 2 in between. You draw a horizontal line here. The graph lies in this space. And if you draw a horizontal line at pi by 2 also, you have 4 parts. So in which parts do the graph lie? When x is positive, y is in the first quadrant. When x is negative, y is in the second quadrant. So in these two parts the graph lies. The range is open 0 to pi. That means the graph has to touch 0 and pi asymptotically. So these two lines have to be touched asymptotically. Cot inverse of 0 is pi by 2, passes through this point. It has to touch these two lines asymptotically. So the graph has to look like this. This is how the graph looks like. Tan inverse is an increasing function. Cot inverse is a decreasing function. Tan inverse is an increasing function. Cot inverse is a decreasing function. Next, we'll also look at the remaining two graphs. Now, let us look at the graphs of cosecant inverse x and secant inverse x. For the cosecant inverse x function, the domain is minus infinity to minus 1 and 1 to infinity. That means this part does not come in the domain of cosecant inverse as well as secant inverse. That means there is no graph corresponding to these values of x. Only for these values of x will you have a graph. And as you can see, in the range 0 is absent. That means this curve will never intersect x. This curve will never intersect y is equal to 0. That is the x-axis. So y is equal to 0 corresponds to the x-axis. That means the graph meets x-axis asymptotically. So whatever number is being not there, that is the point where the graph meets asymptotically. So correspond to y is equal to 0, that is x-axis, the curve meets asymptotically. So now, if x is positive, the values of x are positive, then the values of the angles are in the first quadrant, that is, correspond to these values of x, you have y in the first quadrant, that is, you have graph in this part, correspond to negative values of x, the angles that you get will be negative, that is this part. So you have graph in this part and this part. Now cosecant inverse of 1 correspond to 1, cosecant inverse is pi by 2, corresponding to minus 1, cosecant inverse is minus pi by 2, and the graph meets x-axis asymptotically. So how should the graph look like? The graph has to look like this. From here, the graph has to look like this. So this is how the graph of cosecant inverse x look like. Similarly, if you go to the graph of secant inverse x, here also between minus 1 and 1, there is no graph, because this minus 1 to 1 does not come in the domain of secant inverse. Now if you go to the positive values of x, you get values in the first quadrant, that is in this part. For negative values of x, the values of y is in the second quadrant, that is in this part. Now what is the range of the secant inverse x? 0 to pi except pi by 2. 0 to pi except pi by 2. That means the graph of secant inverse x meets y is equal to pi by 2 asymptotically. So now this is the line which is a asymptote to secant inverse x. How does the graph look like? Let us take a sample point. What is secant inverse of 1? Secant inverse of 1 is 0 and secant inverse of minus 1 is pi. So from these points, it has to meet x is equal to pi by 2 asymptotically. So the graph has to look like this, and also here the graph has to look like this. So if you remember how to draw these graphs, it will be very useful in solving certain problems. So all these 6 graphs should be very well remembered. So let us now look at some of the standard properties or methods of standard simplifications of inverse trigonometric functions. The first property that we are going to look at is how to simplify inverse function corresponding to minus x. It is sine inverse of minus x. So whenever you have sine inverse of minus x, how do you simplify it? So the formula is sine inverse of minus x is minus sine inverse x. So we have already seen that there are 3 inverse trigonometric functions whose ranges are related to minus pi by 2 to pi by 2. Sine inverse, cosecant inverse and tan inverse. So correspond to these 3 inverse trigonometric functions whose ranges are related to minus pi by 2 to pi by 2. This minus directly comes out from the inverse function. Cosecant inverse of minus x is minus cosecant inverse of x. Tan inverse of minus x is minus tan inverse of x. So these are the first 3 formulas. And corresponding to the remaining 3 functions whose ranges are related to 0 to pi is cos inverse of minus x, secant inverse of minus x, cot inverse of minus x. So the formulas are pi minus cos inverse of x, pi minus secant inverse of x, pi minus cot inverse of x. So corresponding to the inverse trigonometric functions whose ranges are related to 0, pi, whose ranges are related to 0, pi, we have cos inverse of minus x is equal to pi minus of inverse trigonometric function corresponding to x. These three functions are having range related to minus pi by 2 to pi by 2. For example, we have already seen this when we have discussed the topic values of inverse trigonometric functions. For example, if you have cos inverse of minus root 3 by 2. So if you draw the quadrant diagram for cos inverse, plus, plus, minus, minus, and the range of cos inverse is 0 to pi. So you need to find an angle whose cos is root 3 by 2. Whose cos is minus root 3 by 2, which lies in the range 0 to pi. So obviously this number is a negative number. So you get an angle in the second quadrant. So first what we do is we find an angle in the first quadrant corresponding to cos inverse of plus root 3 by 2. So cos inverse of plus root 3 by 2 is pi by 6. So cos inverse of plus root 3 by 2 is pi by 6. To get the corresponding angle for cos inverse of minus root 3 by 2, you need to find the allied angle in the second quadrant. That is pi minus of this. So cos inverse of minus root 3 by 2 is pi minus cos inverse of root 3 by 2. So if the range is in 0 to pi, so the logic is pi minus the positive angle. Corresponding to these three functions, the range is minus pi by 2 to pi by 2. So if you get the allied angle in the first quadrant, just need to place a negative sign in front of this angle to get the allied angle in the fourth quadrant. So I hope you understand how to simplify the inverse trigonometric functions corresponding to minus x. So the property 2 corresponds to the simplification of T of T inverse. It is something like sine of sine inverse x. So you have a sine here, you have a sine inverse inside. So sine of sine inverse x is equal to x. Cos of cos inverse x is also equal to x. Tan of tan inverse x is also equal to x. Cot of cot inverse is x. Secant of secant inverse x is also x. Cosecant of cosecant inverse x is also x. That means if the trigonometric ratio is outside, inverse trigonometric ratio is inside, these two functions are getting cancelled. But only if x belongs to the domain of the corresponding inverse trigonometric function. Corresponding inverse trigonometric function. That is, sine of sine inverse x is equal to x as long as x belongs to minus 1 to 1. Because only numbers between minus 1 and 1 can go inside sine inverse. For example, if I ask you to find sine of sine inverse of pi. If the question is sine of sine inverse pi. So if you write the answer as pi, you're going wrong. So this is not equal to pi. So the answer for this is undefined. Why is it undefined? Because pi as a number is 3.14 something. And sine inverse is only defined for numbers between minus 1 and plus 1. So sine inverse pi is not defined. So sine of something not defined is again not defined. Similarly, if I write tan of tan inverse pi, so this will be equal to pi. There's no doubt about it. Because tan of tan inverse x is equal to x works for all real numbers. For all real numbers. Because the domain of tan inverse x is all real numbers. And cosecant and secant. This formula works for all real numbers except minus 1 to 1. So if the question is cosecant inverse of pi by 4. So this might be given to confuse you. So whenever you see cosecant of cosecant inverse, you tend to cancel this, tend to write this as pi by 4, which is again wrong. Why is this wrong? Because cosecant inverse is not defined for pi by 4. So this pi by 4 is somewhere in between -1 to 1. So cosecant inverse is undefined. So cosecant of something undefined is also undefined. So the answer for this is undefined. So all of these are equal to x, but all these are not identical functions. So you will be given questions on identical functions. So you will be asked to check whether sine of sine inverse x and tan of tan inverse x are identical or not. You will be asked to check whether these two are equal functions or not. The answer is no. These two are not equal because the domains are not equal. The domain of this function is -1 to 1. The domain of this function is all real numbers. Next, if you are asked to draw the graphs of these functions, you are asked to draw the graph of y is equal to sine of sine inverse x. So how do you draw this? The trick is this function is defined only between -1 and +1. And the value of this function is equal to x. So the graph is corresponding to y is equal to x, which is a straight line. It is straight line, y is equal to x. So it stops here. The graph of y is equal to sine of sine inverse x stops here. If you are asked to draw the graph of y is equal to tan of tan inverse x, how does the graph of this look like? So this is also equal to x, but this is valid for all real numbers. Means if you draw the graph, so you get y is equal to x, complete line y is equal to x. I hope you understand the difference between this graph and this graph. So this graph corresponds to sine of sine inverse and cos of cos inverse. This graph corresponds to tan of tan inverse and cot of cot inverse. And can you guess how to draw the graph of secant of secant inverse and cosecant of cosecant inverse? It's very easy. So if you take the graph, this is 1, this is -1. Now here the graph does not lie between -1 and +1. Again, this graph is same as y is equal to x, but except this line segment which corresponds to sine. So you get graph like this for y is equal to secant of secant inverse x or cosecant of cosecant inverse x. So I hope you understand what this property says. So if you have trigonometric ratio outside and inverse trigonometric ratio inside, the answer will either be equal to x or will be equal to undefined. You have one of these two answers. So it will be equal to x if this x belongs to the domain of the corresponding inverse trigonometric function. Undefined if x lies outside the domain. So I hope it is clear. Next, the third property deals with the simplification of T inverse of T. That is, inverse trigonometric ratio is outside, trigonometric ratio is inside. This property is the single most important property which you need to master if you want to do questions in advanced exams. So the formula says that sine inverse of sine x is equal to x only if when will sine inverse and sine cancel each other. We have already seen that within a particular domain of sine x, only sine inverse is the inverse of sine. That is, over which domain? Minus pi by 2 to pi by 2, right? So only if this x lies between minus pi by 2 to pi by 2, sine inverse and sine cancels each other. So only if x lies between minus pi by 2 and plus pi by 2. Similarly, cos inverse of cos x will be equal to x if x lies in the restricted domain of cos or x lies in the range of cos inverse. That is, x is in between 0 and pi. Similarly, tan inverse of tan x is again equal to x if x is in between minus pi by 2 and plus pi by 2. That is within the restricted domain of tan or within the restricted range of tan inverse. Similarly, cot inverse of cot x is equal to x if x lies between 0 and pi. Cosecant inverse of cosecant x is equal to x if x lies between minus pi by 2 and plus pi by 2 and x not equal to 0. And similarly, secant inverse of secant x is equal to x if x lies between 0 and pi but x not equal to pi by 2. So within the restricted domains of the trigonometric functions, P inverse of P of x will be equal to x. Now the question remains, what happens to the other values of x? If x lies between these two, the formula is okay. If x does not lie in between these two numbers, so how do you simplify these expressions? So that's what we need to understand in this property. Now, let us try to understand this concept with a few examples. So if you have sine inverse of sine pi by 6, sine inverse of sine pi by 6. So this pi by 6 lies between minus pi by 2 and plus pi by 2. Because pi by 6 is 30 degrees. 30 degrees lies between minus 90 and plus 90. Hence, sine inverse and sine gets cancelled. So you get answer as pi by 6. Similarly, sine inverse of sine. So without laws of generality, I'll put the numbers, I'll put the angles in degrees just for better understanding. So if I want sine inverse of sine 60 degrees, so this will be equal to 60 degrees because 60 degrees lies in the range of sine inverse. Now let us move forward. Sine inverse of sine 90 degrees. Even now sine inverse and sine gets cancelled, so is equal to 90 degrees. Because 90 degrees also lies in the range of sine inverse. Because the range of sine inverse is minus pi by 2 to pi by 2. Now the question is, what do you do if this angle goes beyond 90 degrees? For example, if you have sine inverse of sine 120 degrees. So what is the actual process of simplification? The problem here is, because 120 degrees does not lie in the range of sine inverse, these two cannot be directly cancelled out. So what we do is, we know that sine x is a periodic function. So sine 120 degrees is a number. So this can be written as a sine inverse of, so what is sine 120 degrees? Sine 120 degrees is nothing but root 3 by 2. So from the basics of trigonometry, we know the quadrant diagram for sine theta. The quadrant diagram for sine theta looks something like this. So sine is positive here, positive in the second quadrant, negative, negative. And the range of sine inverse is minus pi by 2 to pi by 2. So if you have sine 120 degrees, so 120 degrees lies somewhere here. So we know that sine 120 is positive. So I want an angle in the range minus 90 to 90 whose value of sine is exactly same as sine 120. So here sine 120 is positive. So what is the allied angle where? Again, sine has the same value as sine 120. So the allied angle lies somewhere here. So these two angles will have the same value of sine. Both are positive, so they have the same sign of number also. So sine 120 degrees is exactly same as sine 60 degrees. Sine 120 degrees is same as sine 60 degrees, right? So sine 120 is root 3 by 2. So this can be written as sine inverse of sine 60 degrees. Now 60 degrees lies in the range of sine inverse. Now these two gets cancelled and the answer is 60 degrees. So sine inverse of sine 120 degrees is 60 degrees. Similarly, you have sine inverse of sine of 150 degrees. So corresponding to 150 degrees, the ray lies here, but this ray lies outside the range of sine inverse. So corresponding to the value of sine 150, I want a particular angle within this range whose sine is same as sine 150. That is nothing but the allied position, right? So the allied position of 150 degrees in the first quadrant is 30 degrees, right? That is just the mirror image. The mirror image of 150 degrees ray on the first quadrant makes an angle of 30 degrees, right? So sine inverse of sine 150 is exactly equal to sine 30 degrees. Now 30 degrees is in the range of sine inverse and the answer is 30 degrees. So sine inverse of sine 150 degrees is 30 degrees. Now if you go to further angles, for example, sine inverse of sine of 210 degrees. So where does 210 degrees lie? So the ray correspond to 210 lies here. Correspond to sine 210. The value is negative because 210 lies in the third quadrant. Now within minus 90 and plus 90, what is the angle which has the same value of sine as sine 210 degrees? Because this is in the negative quadrant of sine, the reflection has to go on to the negative side, right? So 210 degrees is 180 plus 30, so this angle numerically is 30 degrees and this angle numerically is 30 degrees, but it is measured in the negative direction. So this ray corresponds to minus 30 degrees. So sine 210 is exactly equal to sine of minus 30 degrees. Now minus 30 lies in the range of sine inverse and the angle is minus 30 degrees. So I hope you understand the basic process. How to simplify the expression of the form T inverse of T if this angle is not in the range of a particular trigonometric ratio. So now let us look at more examples and see the quadrant diagram for each of the different trigonometric ratios. So let us take these examples. So in this example, you are asked to find sine inverse of sine 1230 degrees, cos inverse of cos 1230, tan inverse tan 1230, cot inverse cot of 1230. So corresponding to each inverse trigonometric ratio, the quadrant diagram changes. So let us go to the first question. So sine inverse of sine 1230 degrees. So let us first draw the quadrant diagram for sine inverse. So plus plus minus minus and the range is minus pi by 2 to pi by 2. Now in this quadrant diagram, let us plot the ray corresponding to 1230 degrees. So 1230 degrees, where does the ray stops? So to do that, let us divide 1230 by 90 degrees. Let us see how many 90s are there. So 190 is a, so 10 90s is 900, 11 90s is 990, 12 90s is 1080, 13 90s, 13 into 90, 7 to 1170 degrees. So 13 times 90 is 1170 and you have an extra 60 degrees. So 1230 degrees is 13 times 90 degrees plus an extra 60 degrees. Now how do we just rotate the ray through 1390 degrees? So 4 times 90, 8 times 90, 12 times 90, 13 times 90 plus an extra 60 degrees. So this small angle is 60 degrees. So that is where the ray stops. Now, what is the quadrant diagram for sine inverse? Let me draw it again. Plus, plus, minus, minus. My ray stops here such that this angle is 60 degrees. That means this angle is 30 degrees. Now this ray lies outside the range. So you have to take this ray into the range by reflection. Positive has to go to positive. So reflect about y-axis. Reflect about y-axis. Now whatever is the angle corresponding to this ray is the answer. So if this is 30 degrees, by reflection this also is 30 degrees. And this ray corresponds to 30 degrees. And the answer here is 30 degrees. Similarly, cos inverse of cos 1230. So corresponding to cos inverse, the diagram looks something like this. My ray is stopping here such that this angle is 30 degrees. Now this ray lies within the range of cos inverse. Hence, whatever is the standard angle corresponding to this ray is the answer. That means whatever is this angle is the answer. So if this is 30 degrees, obviously this angle is 150 degrees. Tan inverse of tan 1230. So what is the quadrant diagram for tan? Plus, plus, minus, minus. So this is the quadrant diagram. So my ray lies here such that this angle is 30 degrees. Now for tan inverse, the reflection is about origin. So this ray has to be sent here. So if this is 30, obviously this angle is also equal to 30 degrees. Hence, this angle, this ray has to be measured in the negative direction. So this corresponds to minus 30 degrees. Hence, tan inverse of tan 1230 is minus 30 degrees. And cot inverse of cot 1230. So if you draw the quadrant diagram for cot, plus, plus, minus, minus. So 1230 degrees corresponds to a ray here. So this ray lies in the range of cot inverse. So you don't need any reflection. So just measure this angle in the standard convention. So whatever is this angle is the answer. So by geometry this is 30 degrees. So this angle obviously is 150 degrees. So this will be equal to 150 degrees. Now let us deal with some more examples. In this video, let us look at important diagrams called quadrant diagrams, which are useful in the simplification of expressions T inverse of T. So corresponding to sine inverse of sin x and cosecant inverse of cosecant x. So corresponding to these two expressions, the quadrant diagram looks something like this. So let us draw the quadrant diagram for sine. So sine is positive, positive, negative, negative. And what is the range of sine inverse and cosecant inverse? Minus pi by 2 to pi by 2. So this diagram is called the quadrant diagram, corresponding to these two inverse trigonometric functions. And this diagram will be useful in solving expressions of this form. For example, if you have sine inverse of sine 280 degrees. 280 degrees, for example. So first what you do is, you can very clearly see that 280 degrees is not in the range of sine inverse. So these two will not get cancelled. So in that case, what you do is, you draw the ray corresponding to the angle 280 degrees. So you know how to draw the ray, right? So what I do is, so I'll rotate the ray through an angle of 280 degrees. So 90 degrees, 180, 270, 280 degrees. So the ray stops somewhere here. Now the ray has stopped in the range of sine inverse. So what you do now is, you just need to find the corresponding angle to this ray measured in the standard convention. So now if you take this ray, what is the standard convention angle correspond to this ray? So we know that if you rotate this by 280 degrees, 270 corresponds to this. So you go an extra of 10 degrees, right? Now, what is the standard angle measured correspond to this ray? If this is 10 degrees, this angle is 80 degrees. But this is measured in this is measured in clockwise direction. So the angle has to be reported as minus 80 degrees. So the answer to this will be just minus 80 degrees. Minus 80 degrees. Next, if you have sine inverse of sine of 240 degrees. So again, 240 degrees also does not lie in the range of sine inverse. So what you first do is, draw the ray corresponding to the angle 240 degrees. So 90, 180. So 240 lies somewhere here. Let this angle be 240 degrees. Now as you can see, the ray lies outside the range of sine inverse. So what you do now is, you bring this ray into this range by appropriate reflection. The positive side has to go to the positive side, the negative side has to go to the negative side. So this ray is in the negative side of sine, so it has to go to the negative side. So just reflect this ray onto the side corresponding to the negative side. So if you reflect this ray, you get a ray like this. So if this is 240, this angle is 60 degrees. So on reflection, this angle numerically is also equal to 60 degrees. Now what is the angle correspond to this ray in the standard convention? Minus 60 degrees. So the value of sine inverse of sine 240 is minus 60 degrees. Minus 60 degrees. So I hope this is clear. So you can solve some of difficult problems using this also. For example, if you are asked sine inverse of sine 3. You are asked to find sine inverse of sine 3. What is the answer? So let us draw the quadrant diagram for this. So here you have to understand degrees is not given and this has to be assumed as radians. So what is the quadrant diagram for this? You are dealing with sine inverse of sine. So plus, plus, minus, minus, and the range is minus pi by 2 to pi by 2. So what is 3 radians? We know that pi corresponds to 3.14 radians. So 3 radians is somewhere near this. So the ray is somewhere here. So this angle is 3 radians. Now this ray lies outside the range. So you have to reflect it onto the positive side. So this is the allied angle. So whatever is this angle is the answer. So what is this angle? Can you measure this? So this angle is 3. This total angle is pi. So what is this small angle? Pi minus 3, right? Pi radians minus 3 radians. So the small angle is pi minus 3. So on reflection, if this angle is pi minus 3, this angle is also pi minus 3. This is measured in positive direction. So the answer for this is pi minus 3. Pi minus 3. As simple as that. Now let us go and see the quadrant diagrams for other inverse trigonometric ratios. Next, corresponding to cos inverse of cos x and secant inverse of secant x. The quadrant diagram looks like this. So what are the signs of cos in the quadrants? Cos is positive here, negative here, negative here. And what is the range of cos inverse and secant inverse? 0 to pi. So this is the quadrant diagram for cos inverse and secant inverse. Now, if the ray stops within the range, so you don't need to reflect it, you just need to measure the angle in the standard convention. If the ray stops in these two quadrants, minus has to be transferred to minus, plus has to be transferred to plus. It is, we are dealing with reflection about x-axis now. For sine inverse and cosecant inverse, we dealt with reflection about y-axis. For cos inverse and secant inverse, the reflection is about x-axis. So what you just need to remember is, negatives has to go to the negative side, positives have to go to the positive side. Now, let us take some examples. So, cos inverse of cos 150 degrees. Cos inverse of cos 150 degrees. So, draw the ray correspond to 150 degrees. The ray lies well within the range, so you don't need to do anything. So, the answer is 150 degrees. Cos inverse of cos 240 degrees. So if you draw the ray correspond to 240 degrees, the ray looks something like this. It lies outside the range. So you have to take this ray into the range by reflection. So negative has to go to the negative side. So on reflection, the ray looks like this. So if this is 240 degrees, this angle is how much? 30 degrees. On reflection, if this angle is 30 degrees, this angle is also 30 degrees. Now correspond to this ray, what is the standard angle? Standard angle has to be measured from the positive x-axis. So from here, what is this angle? 90 degrees plus 30 degrees. So the answer is 120 degrees. What is cos inverse of cos 390 degrees? So plot 390 degrees, corresponding ray. So 360 plus 30. The ray looks something like this. So this is the ray corresponding to 390 degrees. So this is 360 plus this extra angle is 30 degrees. Now, what is the standard angle correspond to this ray? Start with positive x-axis, measure this, turn out to be 30 degrees. Right? This is 30 degrees extra. Hence, the angle is 30 degrees. So, what is cos inverse of cos 3? As we have seen in the previous example. 3 radians lies in the second quadrant. But this time second quadrant lies in the range of cos inverse, hence you don't need to do anything. So 3 is the answer. Don't need to reflect it or anything. Cos inverse of cos 9. What is cos inverse of cos 9? So 9 radians. So this starts with 0. Plus, minus, this is the diagram. So pi by 2 radians, pi radians, 3 pi by 2 radians, 2 pi radians, this is 6.28 radians, plus 1.57, 7.8 radians approximately. Here it is 3 pi radians. 3 pi is 9.4 radians approximately. So this is 7.8 radians, this is 9.4 radians. So 9 lies somewhere in the second quadrant again. So how is 9 visible to you? So one complete rotation plus this is 9 radians. Now this is well within the range of cos inverse. So you don't need to reflect it. Just need to measure this angle correspond to this ray in the standard convention. It is starting with positive x-axis. Starting with positive x-axis. If you measure this angle, that will be the answer. So can you tell me what this angle is? So as you can see, this complete angle is 9. I want this angle. So as you can see, 2 pi radians plus this is 9. So if you take this as x, 2 pi plus x is 9. So what is this angle? X is equal to 9 minus 2 pi. So this will be the answer to cos inverse of cos 9. Cos inverse of cos 9. So let us compare this question with the question sine inverse of sine 9. So let us go slightly previous. So sine inverse of sine 9. So what is the value of sine inverse of sine 9? So let us draw the quadrant diagram for sine inverse. So plus, plus, minus, minus. So the ray correspond to 9 looks somewhere here. So what is the range of sine inverse? This is the range. So this ray now lies outside the range. So I need to reflect it about y-axis. Now whatever is this angle is the answer. So I need you to find this angle. How do we do this? So here you have to use certain geometry. So how do we do this? Let us try to calculate this. So this complete angle is 9 radians. So if I just add this, if I go till here, it is 3 pi radians. What is this small angle here? This total angle is 3 pi. Angle till here is 9 radians. So what is the small angle? Is nothing but 3 pi minus 9. So on reflection, whatever is this angle will get reflected here. So what is this angle? This angle is also equal to 3 pi minus 9. So that will be the answer to this question. So sine inverse of sine 9 is 3 pi minus 9. Cos inverse of cos 9 is 9 minus 2 pi. So depending on what inverse ratio is asked, we have to draw the corresponding quadrant diagrams and try to simplify the number. Now let us also see quadrant diagrams for tan inverse and cot inverse. For tan inverse of tan x, the quadrant diagram looks something like this. So tan inverse of tan x. So we draw the quadrant diagram. Tan is positive in the first and third quadrants, negative in the second and fourth quadrants. And the range of tan inverse is minus pi by 2 to pi by 2. So if you have an angle x, if the ray stops in the range of tan inverse, you can draw the ray and directly find the corresponding angle with the standard convention. If the ray is stopping in these two quadrants, so if the ray stops in the second quadrant, because the second quadrant corresponds to the negative sign of tan, it has to be taken into this fourth quadrant. Third quadrant angles have to be taken into the first quadrant. It is, if you want tan inverse of tan 120 degrees, So 120 degrees ray corresponds to this. Now the reflection should be about the origin, because the negative side has to go to the negative side. So just extend it backwards. So if this is 120 degrees, this is 30 degrees. So if this is 30, on reflection this angle is equal to 30 degrees. So corresponding to this ray, what is the angle? The angle is minus 60 degrees. So tan inverse of tan 120 degrees is minus 60 degrees. So you need to understand here, the reflection will be about origin. So what is cot inverse of cot 120 degrees? So what will be the quadrant diagram for cot inverse? So plus minus, and the range of cot inverse is 0 to pi. Now if you are asked to find cot inverse of cot 120, the ray correspond to 120 lies here. It lies within the range of cot inverse, so you don't need to do any reflections. So just measure this angle, so that angle will be the answer. So clearly this angle is 120 degrees, hence cot inverse of cot 120 is 120. Cot inverse of cot 240 degrees. So draw the quadrant diagram, plus minus, range is 0 to pi. Now 240 degrees is 180 plus 60 degrees. So 240 degrees, the ray lies here. Now this ray lies outside the range of cot inverse. Now you need to reflect it. So positive side has to be reflected to the positive side, negative side has to be reflected to the negative side. So if you reflect the positive side onto the first quadrant, you just need to extend it backwards. So if this angle is 240 degrees, the small angle is 60 degrees. So if this angle is 60 degrees, this angle will also be equal to 60 degrees. Hence cot inverse of cot 240 degrees is 60 degrees. So I hope you are understanding the basics of how to simplify tan trigonometric inverse of trigonometric functions. So let us look at some more general examples. Next, let us say that you have to find sine inverse of sine 10, cos inverse of cos 10, tan inverse of tan 10, cot inverse of cot 10. Degrees are not given, so obviously 10 means radians. If no unit is given, you have to take the angle in radians. Now let us try to find sine inverse of sine 10 using quadrant diagram. First you need to plot this 10. You need to see where 10 radians is. So if you take the quadrant diagram, in radians 0 is pi by 2 radians. So 1/2 rotation is pi radians, 3 pi by 2 radians, 2 pi radians. So 1 pi means 3.14 radians. 2 pi means 6.28 radians. Similarly, if you go one more pi by 2 and one more pi, this corresponds to 3 pi radians. 3 pi is somewhere around 9.42 radians. So you have come very close now. So 6.28 radians, 9.42 radians, plus an extra of 0.5 radians. So 10 radians stops somewhere in the third quadrant. Now what will this small angle be? As you can see, the total angle is 10 radians, and up till here, this angle is 3 rotations, which is 3 pi. So the total angle is 10 radians. The angle till the negative x-axis is 3 pi radians. So this small angle will be 10 minus 3 pi radians. So keep this in mind. You will need this. So the small angle is 10 minus 3 pi radians. Now, let us try to solve one by one. So let us draw the quadrant diagram for sine inverse. So this is plus, plus, minus, minus. Now you have this angle somewhere. You have this ray somewhere here. With respect to sine inverse, the ray is outside the range in the negative side. So on reflection, you have to go to the negative side. So as you can see, magnitude wise, this angle is 10 minus 3 pi. So magnitude wise, this angle is also 10 minus 3 pi. But the angle corresponding to this ray is negative. So the answer here is minus of 10 minus 3 pi. Whatever is the angle with the negative sign. Next, cos inverse of cos 10. Plus, plus, minus, minus, and 0 to pi. This is the quadrant diagram for cos inverse. Now my ray is in the third quadrant. So on reflection, you have to take the negative side onto the negative side. So you have to reflect about x-axis. So as you can see, this small angle is 10 minus 3 pi. So this angle is also 10 minus 3 pi. So what is the angle that you need to report? The conventional angle. This angle is the answer. So if this angle is 10 minus 3 pi, what will this angle be? Pi minus of 10 minus 3 pi. That is nothing but 4 pi minus 10. Pi plus 3 pi is 4 pi minus 10. Next, tan inverse of tan 10. So let us draw the quadrant diagram for tan inverse. So let us do it here. So plus, plus, minus, minus, and minus pi by 2 to pi by 2. Now, the reflection. So the ray is somewhere here. And this angle is 10 minus 3 pi. Now the reflection here is about origin. So you have to go here. And whatever is this angle is the answer. So as you can see, these are vertically opposite angles. So if this is 10 minus 3 pi, this is also equal to 10 minus 3 pi. So tan inverse of tan 10 is 10 minus 3 pi. Last, what is cot inverse of cot 10? So let us draw the quadrant diagram here. So corresponding to cot, plus, plus, minus, minus, and this is the range. Now the ray is somewhere here. The ray is somewhere here. So here also the positive side has to be reflected onto the positive side. Because the ray lies outside the range, you have to take this within the range. So again the reflection is in the opposite direction, exactly same as this. So you get the exact same angle, 10 minus 3 pi as the answer. So I hope you understand how to simplify tan trigonometric inverse of trigonometric function. So if the inverse is outside, then the situation is tricky and you need to go for quadrant diagrams. I hope this is very clear. In this video, let us try to understand the graphs of T inverse T functions. So first let us try to look at the graph of sine inverse of sin x is equal to y. Y is equal to sine inverse of sin x function. As we have seen, sine inverse of sin x is equal to x if x belongs to minus pi by 2 to plus pi by 2. That is between minus pi by 2 to pi by 2, the graph is just y is equal to x. It is a straight line graph. So minus pi by 2 corresponds to minus pi by 2, plus pi by 2 corresponds to plus pi by 2. You have a straight line graph. So between minus pi by 2 and plus pi by 2, sine inverse and sine will exactly cancel each other. So y will be exactly equal to x. Next, what happens after this? So this will be very clear from the quadrant diagram. Just need to run a small animation in your brain. So if you draw the quadrant diagram, sine plus plus minus minus. So this is the quadrant diagram. So as the angle increases, imagine a ray rotating about origin. So till 0 to 90, you get exactly y is equal to x. Now, as the angle increases, you won't get x as the answer. We have already seen that you get the reflection of this about y-axis as the answer. So as the angle increases, the reflection moves back again towards x-axis. So as this angle, its reflection moves back about towards x-axis. And when the angle is pi, the answer again goes back to 0. So from pi by 2, as the angle increases to pi, the value of y goes back to 0. Now as the angle still moves forward, as the angle increases more than 180 degrees, the reflection goes to the negative angles. That means the answers will be negative angles, and the angles increases till minus 90. It is minus pi by 2. The angles increases till minus pi by 2. And then as the angle increases, the ray goes into the range. So the ray goes closer and closer to x-axis again. It means the angle that comes out goes back to 0. So as the angle increases, the answers have gone till pi by 2 and then gone back to 0, went to the negative side and come back to 0 again. So the graph looks like this, and it continues as we go forward. So on this side also it looks the same. So again, sine inverse of sine x is a periodic function. As you can see, this part of the graph repeats again and again. It is a periodic function, again with a period of 2 pi. And what is the domain of this function? The domain of this function is all real numbers. Any real number can go inside this function, but the range is minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2 is the range. So this is about the graph of sine inverse of sine x. Next, let us try to understand the graph of y is equal to cos inverse of cos x. As we have seen, cos inverse of cos x is equal to x if x belongs to 0, pi. So as long as x is in between 0 and pi, the graph is y is equal to x. That is, that x is equal to 0, y is equal to 0, and x is equal to pi by 2, y is equal to pi by 2. When x is equal to pi, y is equal to pi. So you have a straight line graph between 0 and pi, exactly at an angle of 45 degrees. Now the question is, what happens as the angle increases? Again, you can see from the quadrant diagram. So plus plus minus minus. So as the ray goes from 0 to 180 degrees, you get the exact same numbers as the answers. Now, as the angle increases beyond 180, so the answer will be the angle corresponding to the corresponding reflection. That means as the angle is increasing, the angle corresponding to the reflection is again decreasing. When the angle is 270 degrees, corresponding to the reflection, the angle is 90 degrees. As it comes here, the reflection is in the first quadrant. as it goes here, again the reflection goes closer and closer back to 0. So at 3 pi by 2, the answer goes to pi by 2. At x is equal to 2 pi, the angle, which is the answer, goes back to 0 degrees. So again it comes down. Then again it goes up and comes down. Same happens on this side. If the angle is going to be negative, the reflection is a positive angle, acute angle. So for corresponding negative angles, you get the answers as positive. So this is how the graph goes. This graph also has period of 2 pi. A period of 2 pi. And this is also a periodic function with period 2 pi. And the domain is again all real numbers, and the range is 0 to pi. So the same cos inverse of cos x function and the secant inverse of secant x function, both graphs are exactly same. Sine inverse of sine x and cosecant inverse of cosecant x, both have same graphs because both have same quadrant diagrams. So if the quadrant diagram changes, the graph changes. So let us now look at the graph of tan inverse of tan x. Next, let us look at the graph of y is equal to tan inverse of tan x. As we have seen initially, this will be equal to x if x belongs to minus pi by 2 to plus pi by 2. That is, between minus pi by 2 to pi by 2, y is exactly equal to x. So what is the slight difference here? Tan is not defined at plus or minus pi by 2's. So tan inverse of tan x will also be not defined at plus or minus pi by 2. So this y is equal to x works close and close and close to pi by 2, but not exactly at pi by 2. So usually we denote it by a hollow dot. That means this goes closer and closer and closer, tends to pi by 2, but exactly at pi by 2, the function is not defined. So let us draw the quadrant diagram to understand what happens beyond pi by 2. If you draw the quadrant diagram, plus plus minus minus. So till pi by 2 you get the same angle, but once the angle crosses pi by 2, this time the reflection won't be along the y-axis. The reflection will be along origin. That means as immediately after it crosses 90 degrees, the answer suddenly jumps to negative angles. The answer goes closer and closer to minus pi by 2. There is a certain jump. Till 90 degrees, the answer is positive. As it crosses 90 degrees, suddenly it jumps to minus 90 degrees. And next, as the ray moves, it again comes back to 0. Again goes back to 0. So what happens is at pi by 2, the graph jumps to minus pi by 2. The graph jumps to minus pi by 2. And then again it starts rising. Starts with minus pi by 2 and starts rising again. Means the graph looks like this. Again, exactly as it crosses 3 pi by 2, the angles will again start with minus pi by 2. So you have a jump here, and again the graph moves. So here also you get the exact same graph on the negative side. So you have a seesaw shaped graph for tan inverse of tan x. Saw shaped graph. And this graph is discontinuous at odd multiples of pi by 2. And it is periodic with a period of pi. This graph is periodic with a period of pi. So period of tan inverse of tan x is pi, is a saw-shaped graph. The domain is all real numbers except odd multiples of pi by 2. The range is open minus pi by 2 to plus pi by 2. So these are the things that we need to understand about tan inverse of tan x. Let us finally look at the graph of y is equal to cot inverse of cot x. We have seen that cot inverse of cot x is equal to x if x belongs to 0, pi. When x belongs to 0, pi. So between 0 to pi, the graph is y is equal to x. Y is equal to x. And as we know, cot is not defined. Cot is not defined at the values where sine is equal to 0. Because cot is cos by sine. Sine is 0 at even multiples of pi by 2, that is at x is equal to 0 and x is equal to pi. Cot is not defined. So between these two, y is equal to x. And if you draw the quadrant diagram, plus, minus, minus, and the range is 0 to pi. So if the ray crosses 180 degrees, suddenly the answer jumps to the positive quadrant. Okay, suddenly the jump happens as it crosses pi, the jump happens to 0, and again it starts going up. And then again it crosses 2 pi, it comes back to 0, it goes up. Here also the same thing happens. So this is also a saw-shaped curve, but it extends between 0 to pi. That's the only difference. Tan inverse of tan x extends between minus pi by 2 to pi by 2. Cot inverse of cot x extends between 0 to pi. So it is also a saw-shaped curve. Domain is all real numbers except multiples of pi, and the range is open 0 to pi. I hope you understand all the graphs. Now we have already seen that secant inverse of secant x and cosecant inverse of cosecant x have very close graphs to their reciprocals. There is a small change. Let us just discuss that and go forward. So if you want to draw the graph of y is equal to cosecant inverse of cosecant x, this graph will be exactly same as sine inverse of sine x. There is you have a graph which looks like this. What is the only difference between cosecant inverse of cosecant x and sine inverse of sine x? So this is the graph of cosecant inverse of cosecant x, sine inverse of sine x. The difference is cosecant is not defined for some values of x. So wherever sine x is 0, cosecant x is not defined. So sine x graph is continuous, but cosecant x graph has hollow dots here. You have a hollow dot here. That means cosecant inverse of cosecant 0 is not defined. Similarly, at x is equal to pi, you have a hollow dot. At x is equal to 2 pi, you have a hollow dot. Minus pi, minus 2 pi, you have hollow dots here. These are the extra features of cosecant inverse of cosecant x. The same thing happens for secant inverse of secant x. How does the graph of cos inverse of cos x look like? This, right? So secant inverse of secant x will not be defined when x is equal to, when cos x is equal to 0. When cos x is equal to 0. That is, x is equal to odd multiples of pi. So you have hollow dots corresponding to odd multiples of pi. So correspond to pi by 2 you have a hollow dot, 3 pi by 2, 5 pi by 2, 7 pi by 2, so on. So you have hollow dots here. And the remaining graph is exactly same as cos inverse of cos x. So remember that you need to remember these graphs nicely. It's not that in the exam you need to think about this and draw the graphs. So if you remember these, a high level question based on these can be solved very easily. So property 4 is called 1 by x property. So the formulas that you have in this property is sine inverse of 1 by x is equal to cosecant inverse of x. So if you convert sine inverse into cosecant inverse, the argument gets reciprocated. Similarly, cosecant inverse of 1 by x is equal to sine inverse of x. Cos inverse of 1 by x is equal to secant inverse of x. Secant inverse of 1 by x is equal to cos inverse of x. And tan inverse of 1 by x is equal to cot inverse of x. And cot inverse of 1 by x is equal to tan inverse of x. All these are good, but this property, these properties hold good for all values for which these are defined. But tan inverse of 1 by x is equal to cot inverse of x. Cot inverse of 1 by x is equal to tan inverse of x is valid if x is positive. That is, if x is greater than 0. If x is positive. Tan inverse of 1 by x is equal to minus pi plus cot inverse x if x is negative. That is, x is less than 0. Similarly, cot inverse of 1 by x is equal to pi plus tan inverse of x if x is negative. So if x is negative, you have separate formulas. So tan inverse of 1 by x is equal to minus pi plus cot inverse x. Cot inverse of 1 by x is equal to pi plus tan inverse x. So let us look at the logic behind these formulas. So let us try to derive this property. Sine inverse of 1 by x is equal to cosecant inverse x. So how do you convert from one inverse trigonometric ratio to another inverse trigonometric ratio? So first we start with, let sine inverse of 1 by x is equal to theta. So let sine inverse of 1 by x is equal to theta. So if x is positive, theta lies in the first quadrant. If x is negative, theta lies in the fourth quadrant. So now this implies, so if you apply sine on both sides, sine of sine inverse of 1 by x is equal to sine theta. So sine of sine inverse 1 by x, as long as 1 by x is in between minus 1 and plus 1, these two gets cancelled. So 1 by x is equal to sine theta. So this implies x is equal to cosecant theta, 1 by sine theta. This implies cosecant inverse of x is equal to cosecant inverse of cosecant theta. Now as we have seen, for positive x, theta lies in the first quadrant. For negative x, theta lies in the fourth quadrant. So wherever theta lies, theta is in the range of cosecant inverse. So these two are getting cancelled. So theta is equal to cosecant inverse of x, and theta is also equal to sine inverse of 1 by x. So sine inverse of 1 by x is equal to cosecant inverse of x. So a similar derivation can be thought of for cos inverse of 1 by x is equal to secant inverse of x, because both the ranges are same, so you get exactly the same derivation. Now let us go for derivation for tan inverse of 1 by x. Let us see why you get two different formulas correspond to positive x's and negative x's. Let us look at why there is a difference in the formulas for negative values of x. If x is negative, tan inverse of 1 by x is minus pi plus cot inverse x, and cot inverse of 1 by x is pi plus tan inverse of x. First, let us try to understand this using the quadrant diagram. So if you draw the quadrant diagram for tan inverse, so tan is positive in these two and negative in these two, and the range of tan inverse is minus pi by 2 to pi by 2. Now, if x is negative, obviously 1 by x is a negative number. So if a negative number goes inside tan inverse, the answer will be in which quadrant? The answer will be in the fourth quadrant. That is, if x is negative, tan inverse of 1 by x is in the fourth quadrant. That is, this is a negative angle in the fourth quadrant. Now, cot inverse of x. If you take cot inverse of x, because x is negative, so a negative number is going inside cot inverse. So obviously you get an angle in the second quadrant, because the quadrant diagram for cot inverse is something like this: plus minus, and the range is from 0 to pi. So if a negative number goes inside cot inverse, you get an angle, you get an answer in the second quadrant. But tan inverse of 1 by x and cot inverse of x have to be allied angles. They have to be allied angles. So if you draw both the diagrams on the same diagram, so tan inverse of 1 by x is an angle here. Cot inverse of x is an allied angle to this angle in the second quadrant. So this side is something like, for example, if you get minus pi by 3 here, if this angle is minus pi by 3, cot inverse of x will be its allied angle, which is 2 pi by 3. So from 2 pi by 3, if you want to get minus pi by 3, what should you do? So from cot inverse of x, you have to subtract a pi. From cot inverse of x, you have to subtract a pi, so that this value becomes equal to tan inverse of 1 by x. Similarly, you do the same thing for cot inverse. Now if x is negative, 1 by x is negative, so cot inverse of 1 by x, because the range is from 0 to pi, this angle is in the second quadrant, and tan inverse of x, because x is negative, is in the fourth quadrant. You get an angle. The LHS is an angle in the second quadrant, RHS is an angle in the fourth quadrant, but these two angles are allied angles. Hence, what should you do to get this angle here? So to get this angle here, you have to add a pi. So here you have to add a pi. For example, if you put 1 by x is equal to minus root 3. So if 1 by x is minus root 3, that is x is minus 1 by root 3. So cot inverse of minus root 3 is pi minus cot inverse of root 3. So cot inverse of root 3 is pi by 6. So pi minus, you get 5 pi by 6 as the answer. Now tan inverse of minus 1 by root 3 is minus pi by 6. So what should you do to get this 5 pi by 6 from minus pi by 6? You have to add a pi. So I hope you understand what we are dealing with in these formulas. So you just need to make sure that the LHS and RHS are equal. And you can add a pi or subtract a pi because we are dealing with allied angles. So what are allied angles? We have discussed that in the chapter of trigonometry. So now we'll go forward to the further properties. Next, let us assume that x is negative. So the second case is let x be less than 0. That is, x is in between minus 1 and 0. So this implies, so if a negative number goes inside sine inverse, a negative number goes inside sine inverse. So where does alpha lie? So alpha belongs to minus pi by 2 comma 0. The answers for sine inverse x is from minus 90 to 0. Similarly, where does beta lie? If a negative number goes inside cos inverse, the answer goes to the second quadrant. That is, beta belongs to pi by 2 comma pi. And now from the derivation, sine inverse x is equal to alpha and cos inverse x is equal to beta implies x is equal to sine alpha, x is equal to cos beta. This implies sine alpha is equal to cos beta. So now alpha is in the fourth quadrant, sine alpha is negative, beta is in the second quadrant, so cos beta is also negative. So cos beta can be written as sine of cos beta can be written as, so beta is in pi by 2 and pi. So sine cos beta can be written as sine of pi by 2 minus beta, right? So sine of pi by 2 minus beta is cos beta. Now beta is in between pi by 2 and pi. So pi by 2 minus beta is in between 0 and minus pi. So this is also in fourth quadrant. This alpha is also in fourth quadrant. So both these angles are in fourth quadrant. Hence, these two have to be equal. Because within the fourth quadrant, sine alpha is equal to sine something implies that these two angles have to be equal. This implies alpha is equal to pi by 2 minus beta. So alpha plus beta is again equal to pi by 2. So even if x is positive or negative, sine inverse x plus cos inverse x is always equal to pi by 2. And you can observe this from examples also. So let us take x is equal to half. Sine inverse half is pi by 6. Cos inverse of half is pi by 3. One is 30 degrees, the other is 60 degrees. The sum is 90 degrees. So if you put x is equal to minus half, this number becomes minus pi by 6 and this number is more than pi by 2. So cos inverse of minus half is 2 pi by 3. It is 120 degrees. So this number is more than 90 and this number is slightly negative. And combinedly 120 minus 30 is again equal to 90 degrees. So I hope you understand this property. The derivation again is not required. So if you understand it well enough and if you try it by yourself, that is very well. And these are the properties which you need to remember. And these can be directly used in solutions of some problems. Next, let us assume that x is negative. So the second case is let x be less than 0. That is, x is in between minus 1 and 0. So this implies, so if a negative number goes inside sine inverse, a negative number goes inside sine inverse. So where does alpha lie? So alpha belongs to minus pi by 2 comma 0. The answers for sine inverse x is from minus 90 to 0. Similarly, where does beta lie? If a negative number goes inside cos inverse, the answer goes to the second quadrant. That is, beta belongs to pi by 2 comma pi. And now, from the derivation, sine inverse x is equal to alpha and cos inverse x is equal to beta implies x is equal to sine alpha, x is equal to cos beta. This implies sine alpha is equal to cos beta. So now alpha is in the fourth quadrant, sine alpha is negative, beta is in the second quadrant, so cos beta is also negative. So cos beta can be written as sine of cos beta can be written as, so beta is in pi by 2 and pi. So sine cos beta can be written as sine of pi by 2 minus beta, right? So sine of pi by 2 minus beta is cos beta. Now beta is in between pi by 2 and pi. So pi by 2 minus beta is in between 0 and minus pi. So this is also in fourth quadrant. This alpha is also in fourth quadrant. So both these angles are in fourth quadrant. Hence, these two have to be equal. Because within the fourth quadrant, sine alpha is equal to sine something implies that these two angles have to be equal. This implies alpha is equal to pi by 2 minus beta. So alpha plus beta is again equal to pi by 2. So even if x is positive or negative, sine inverse x plus cos inverse x is always equal to pi by 2. And you can observe this from examples also. So let us take x is equal to half. Sine inverse half is pi by 6. Cos inverse of half is pi by 3. One is 30 degrees, the other is 60 degrees. The sum is 90 degrees. So if you put x is equal to minus half, this number becomes minus pi by 6 and this number is more than pi by 2. So cos inverse of minus half is 2 pi by 3. It is 120 degrees. So this number is more than 90 and this number is slightly negative. And combinedly 120 minus 30 is again equal to 90 degrees. So I hope you understand this property. The derivation again is not required. So if you understand it well enough and if you try it by yourself, that is very well. And these are the properties which you need to remember. And these can be directly used in solutions of some problems. Now let us take a numerical example. So let us say that you have secant inverse of minus 4. You need to convert this into some sort of tan inverse. So how do we do it? So first let us use the triangle method. So first let us say that we are dealing with minus 4. So let us first deal with plus 4 and then adjust the formulas. So secant inverse of minus 4. So hypotenuse is 4, adjacent side is 1. So from this the opposite side becomes root of 16 minus 1 is root 15. So basically secant inverse of minus 4 will be equal to tan inverse of root 15 by 1. These two will be allied positions. Now this angle secant inverse of minus 4, this angle is in the second quadrant, right? Because when a negative number goes inside secant inverse, the answer is in the second quadrant. Here tan inverse of root 15 is a positive number. That means you get an angle in the first quadrant, but you get allied positions. That means you get the reflection. The allied position to this in the first quadrant is the reflection. Now LHS, represents this number, RHS represents this number. So what is the relation between these two? Pi minus of this angle is equal to this angle, or pi minus of this angle will be equal to this angle. So if this is theta, this will be pi minus theta, right? The allied position in the second quadrant. So secant inverse of minus 4 can be written as pi minus of tan inverse of root 50. This is one way. What is the other way? Using property 1. So secant inverse of minus x is straightly equal to pi minus of secant inverse of x, right? Because the range is related to 0 to pi, hence whenever you have minus x, so it will convert into pi minus of this. And once you have a positive number inside secant inverse, you can directly use the triangle method. So this is equal to pi minus tan inverse of root 50. So as you can see, you got the same answer. So it doesn't really matter what in numerical questions. You don't need to remember the formulas also. Whenever you have a negative number, using property 1, convert the number into a positive number, then directly use a triangle method for conversion. The next property is about conversions. It is, if you have something like sine inverse of x, and if you want to convert this into cos inverse of something. So sine inverse of x is equal to cos inverse of what? Or if you want to convert sine inverse into tan inverse. So sine inverse of something is equal to tan inverse of what? Similarly, secant inverse of what? Cosecant inverse of what? Cot inverse of what? So this is what we are trying to understand. So first, easy conversions happen when x is positive. So first let us do the straightforward derivations. So if x is positive, that is x is in between 0 and 1. So if you take sine inverse of x, so let us assume that this is cos inverse of some y. So let us see what y is. So let us try to understand what y is. So sine inverse of x is equal to cos inverse of y. So let us assume sine inverse of x is equal to alpha. Let us say cos inverse of y is equal to beta. So because x is positive, sine inverse x lies in the first quadrant. So cos inverse y also has to lie in the first quadrant. So y has to be also positive. So if sine inverse x is equal to alpha, then x is equal to sine alpha. And cos inverse y is equal to beta implies y is equal to cos beta. So x is equal to sine alpha, y is equal to cos beta. You need to find what y is in terms of x. Now since alpha is equal to beta, cos beta can be written as cos alpha, or cos alpha can be written as root of 1 minus sine square alpha, and sine alpha is x, that is root of 1 minus x square. So y is equal to root of 1 minus x square. That means sine inverse x can be written as cos inverse of root of 1 minus x square. Similarly, you can convert sine inverse into tan inverse using appropriate identities. But what we shall do is, in the exam, you cannot directly do this derivations, it is time taking. So let us try to understand the shortcut by which you can go from one inverse trigonometric ratio to another inverse trigonometric ratio. The shortcut process that we use for conversions is called the triangle method. triangle method. This is very similar to the triangle method which you apply in the chapter of trigonometry to find the other trigonometric ratios if one trigonometric ratio is given. If sine theta is equal to 1 by 3, find the other trigonometric ratios. This is a very standard question which we deal in trigonometry. So let us just revise what we have done. So if sine theta is equal to 1 by 3, find other trigonometric ratios. If this is the question. So how did we do this? We draw triangle, the 90 degrees here, and we mark this as theta. So I am doing this with the help of triangle method. So sine theta is 1 by 3, so we write the opposite side as 1 and the hypotenuse as 3. Because sine theta is opposite side by hypotenuse. So sine theta is 1 by 3. So from these two numbers, using Pythagoras theorem, you can find what this length is. So this length is root of 3 square minus 1 square. It is root 8. So this can be written as 2 root 2. So this has been found using Pythagoras theorem. So whenever a ratio is given, two sides can be written and the third side can be found out from Pythagoras theorem. Now sine theta is given as 1 by 3. So cos theta numerically has to be equal to adjacent side by hypotenuse. That is 2 root 2 by 3. Tan theta is opposite side by adjacent side. 1 by 2 root 2. So this is how you find the trigonometric ratios using triangle method. If you want cot theta, you go adjacent side by opposite side, 2 root 2 by 1. If you want secant theta, 3 by 2 root 2. If you want cosecant theta, 3 by 1. This is the triangle method which helps you in finding the remaining trigonometric ratios if one of them is given. Now the same triangle method will be useful in conversions from one inverse trigonometric function to another inverse trigonometric function. Now, so let us say we need to convert sine inverse x into other trigonometric ratios. So let sine inverse x is equal to theta. That means sine theta has to be equal to x. If sine inverse x is equal to theta, sine theta has to be equal to x. So if you draw a triangle, a right angle triangle with theta here, so sine theta has to be equal to x. That means the opposite side is equal to x and the hypotenuse has to be equal to 1. Such that opposite side by hypotenuse is x. Now once you know these two sides, can you find the remaining side using Pythagoras theorem? Yes. This will be root of 1 minus x square. Now this theta, which is sine inverse x, what is it also equal to? So sine inverse of opposite side by hypotenuse will be equal to cos inverse of adjacent side by hypotenuse. So sine inverse of x is equal to cos inverse of root of 1 minus x square. This is equal to tan inverse of opposite by adjacent, x by root of 1 minus x square. And if you want to convert into others, secant inverse of hypotenuse by adjacent side, 1 by root of 1 minus x square is equal to cosecant inverse of hypotenuse by adjacent by opposite side, 1 by x, is equal to cot inverse of adjacent side by hypotenuse, root of 1 minus x square by x. So this is how you convert one inverse trigonometric ratio into others. So you can have a lot of different conversions. So you just need to use the triangle method and get the answers. So remember, these conversions will be exactly valid only for positive numbers, because when x is positive, all these numbers are positive and all of them lie in the first quadrant. So let us also see what happens if x is negative with some examples. Let us look at a very easy sample question based on the conversions. In this question you are asked sine inverse of 2xy by x square plus y square is equal to cos inverse of what is equal to tan inverse of what. So you want to convert sine inverse of this into cos inverse and tan inverse. So how do we do this? So let us try to use our triangle method. So let us draw a triangle. So let us say this is equal to some theta. So sine theta, if you plot this as theta, sine theta has to be this by this. So opposite side is 2xy and the hypotenuse is x square plus y square. Opposite side is 2xy, the hypotenuse is x square plus y square. Now, using these two sides, let us try to find the third side. Third side is nothing but root of x square plus y square whole square minus 2xy whole square is 4x square y square. So x square plus y square whole square minus 4x square y square is nothing but root of x square minus y square whole square. That is equal to mod of x square minus y square. So this side will be equal to mod of x square minus y square. Now once you got all the sides, sine inverse of opposite side by hypotenuse is equal to cos inverse of adjacent side by hypotenuse mod of x square minus y square by x square plus y square is equal to tan inverse of opposite side by adjacent side 2xy by mod of x square minus y square. So I hope you understand how we are converting from one inverse to another inverse using triangle method. So now let us see what manipulations we need to do if the arguments are negative. Now let us try to understand what happens if the arguments are negative. For example, if you have sine inverse of x and x is negative, this will be equal to what in terms of cos inverse? So if I convert this into cos inverse, previously the formula is cos inverse of root of 1 minus x square. Now if x is negative, what difference does it make? So let us try to understand this with an example. So let us take x is equal to minus half. So let us see why these two are not equal if x is negative. So sine inverse of minus half, x is negative, negative number going inside sine inverse. So the answer is in fourth quadrant. So this answer LHS is minus pi by 6. So if you draw the quadrant diagram, the answer is somewhere here. Now if you find this, cos inverse of root of 1 minus half whole square is 1 by 4. 1 minus 1 by 4 is 3 by 4. Root of 3 by 4 is root 3 by 2. Cos inverse of root 3 by 2 is the first quadrant. So x is negative, but root of 1 minus x square is positive because square root is positive. So root 3 by 2 cos inverse is equal to pi by 6. So as you can see, whatever angle you're getting and whatever angle you're getting here, these two are allied positions. These two are allied positions. The only difference is that because x is negative, this answer lies in the fourth quadrant, this answer lies in the first quadrant. If these two have to be equal, what is the manipulation that I need to make? I just need to put a minus here. So if I put a minus here, minus of this, now these two are equal. So if x is negative, sine inverse of x is minus of this. So is equal to. That means you can use the triangle method with a slight manipulation. So if you draw the triangle like this, this is theta, x1 root of 1 minus x square, so is equal to tan inverse of x by root of 1 minus x square. So if x is negative, this is negative, the denominator is positive, whole number, this complete number is negative, negative by positive. So if a negative number goes inside tan inverse, again you get an angle in the fourth quadrant. So here this is also in fourth quadrant, this is also in fourth quadrant. So these two will be equal. You don't need to do any manipulation. Is equal to cot inverse of x by root of 1 minus x square by x, right? Now, what is happening here? X is negative, root of 1 minus x square is positive. So effectively you got a negative number. So cot inverse of negative number, you get an answer in second quadrant. That means the LHS is minus pi by 6. But the RHS is the allied position to this in the second quadrant. So this side you are getting 5 pi by 6. So let us use this example and see. If x is minus half, cot inverse of 1 minus 1 by 4 is 3 by 4. So root 3 by 2 by minus 1 by 2. 2 and 2 gets cancelled. So you are getting cot inverse of minus root 3. Negative angle in the second quadrant correspond to root 3, you get pi by 6. So pi minus pi by 6 is the answer. So the answer on the right hand side is 5 pi by 6. So what should you do to bring this 5 pi by 6 to minus pi by 6? LHS is minus pi by 6. So if this and this have to be equal, what you need to do is you need to subtract a pi from this, right? So sine inverse of x is equal to cot inverse of root of 1 minus x square by x minus pi is the answer. So you just need to play with plus and minus signs, pi and minus pi. You have to go on changing between the allied positions. So take an example and see what you need to do, and that becomes a formula. So cot inverse of tan inverse of x by root of 1 minus x square becomes cot inverse of this minus pi. So if you want to convert this into secant inverse, so that will be minus secant inverse of 1 by root 1 minus x square. Because root 1 minus x square is positive, this number is positive in the first quadrant, so you just need to go to fourth quadrant, need to add a minus. So I hope you're getting what you need to do if the arguments are negative. The triangle, basic triangle method works. So you get the basic formula using the triangle method, and after that, based on which quadrants the answers lie, you have to shift the answer. So now let us look at these very simple questions. So in the first question, you're asked to find tan inverse 1 plus tan inverse 2 plus tan inverse 3. So tan inverse 1 is very straightforward. We know that tan inverse 1 is pi by 4. So this is quite simple. So let us try to find what this sum is. If you want to find tan inverse 2 plus tan inverse 3, you can see that both 2 and 3 are positive numbers, and you have tan inverse x plus tan inverse y. So there are two formulas for this. One when xy is less than 1 and other when xy is greater than 1. So multiply 2 and 3. So you get 6 as the answer. You get 6 as the answer. Now, is 6 greater than 1 or less than 1? 2 into 3 is equal to 6 is greater than 1, right? So we have to use the second formula. So the expression becomes tan inverse of 1 plus, this is the second formula, that is pi plus tan inverse of x plus y 2 plus 3 by 1 minus 2 into 3. It is tan inverse 1 plus pi plus tan inverse of 5 by minus 5. 2 plus 3 is 5. 1 minus 6 is minus 5. So 5 by minus 5 is minus 1. So tan inverse of 1 plus tan inverse of minus 1. And in the negative x formulas, we have seen that tan inverse of minus x is minus tan inverse x. So tan inverse of 1 plus pi minus tan inverse of 1. These two are getting cancelled. So you get pi as the answer. So this is the solution to the first question. Now let us go to the second question. So here also tan inverse 1, you know that it is pi by 4. So let us add these two. X, y. What is x into y? It is 1 by 6, which is less than 1. That means I can now directly apply the formula. So tan inverse 1 plus tan inverse of x plus y by 1 minus x into y. That is tan inverse 1 plus tan inverse of 3 plus 2, 5 by 6 by 6 minus 1 is again 5 by 6. These two are getting cancelled. So that is tan inverse of 1. So tan inverse of 1 is pi by 4. Tan inverse of 1 is again equal to pi by 4. So the answer is pi by 2. So tan inverse of 1 plus tan inverse of 2 plus tan inverse of 3 is pi. Tan inverse 1 plus tan inverse of 1 by 2 plus tan inverse of 1 by 3 is pi by 2. So these are very standard questions. It will be useful for you to directly remember the answers for these two questions. In this question, we are asked to prove that if tan inverse x plus tan inverse y plus tan inverse z is equal to pi, then this condition happens. X plus y plus z is equal to xyz. The second question states that if the sum is equal to pi by 2, then this condition has to be valid. So let us try to prove one by one. So first, tan inverse x plus tan inverse y plus tan inverse y is equal to pi minus tan inverse z. I am sending tan inverse z onto that side. Remember, this is a very standard type of questions that you will be asked in general subjective examinations. So first what you need to do is you have to send one of the term onto the RHS. Next, tan inverse x plus tan inverse y. So let us apply the formula for tan inverse x plus tan inverse y and apply tan on both sides. Now tan of tan inverse x plus tan inverse y is equal to tan of pi minus tan inverse of z. That is equal to, now tan inverse x plus tan inverse y, depending on what xy is, is equal to tan inverse of x plus y by 1 minus xy or pi plus tan inverse of x plus y by 1 minus xy. So this will be either this or this. In both cases, on application of tan of tan inverse gets cancelled and tan of pi plus theta is again tan theta, and tan inverse directly gets cancelled. Here in the second case, tan of pi plus theta is tan theta, so tan of tan inverse is again x plus y by 1 minus xy. So in both these cases, on application of tan, you get x plus y by 1 minus xy. So this is equal to tan of pi minus theta is minus tan theta. So minus tan of tan inverse z that is equal to minus z. So if you do the cross multiplication, you get x plus y is equal to xyz minus z, and this implies x plus y plus z is equal to xyz. X plus y plus z is equal to xyz. So that is what you're asked to prove in the first question. So next question also we do this exact same thing. Tan inverse x plus tan inverse y is equal to pi by 2 minus tan inverse z. Now if you apply tan on both sides, this side will become x plus y by 1 minus xy is equal to tan of pi by 2 minus theta is cot theta. Cot of tan inverse z. So tan inverse z can be written as cot inverse of 1 by z. So now these two will get cancelled. So this implies x plus y by 1 minus xy is equal to 1 by z. This implies xz plus yz is equal to 1 minus xy. And this implies xy plus yz plus zx is equal to 1. So that's what is the second condition which is being asked. Next, let us look at these questions. So in the first part, you are asked to prove that 2 tan inverse 1 by 3 plus tan inverse 1 by 7 is equal to pi by 4. Now, the 2 tan inverse 1 by 3 is nothing but tan inverse 1 by 3 plus tan inverse 1 by 3. So this is of the form tan inverse x plus tan inverse y. Now let us multiply these two. 1 by 3 into 1 by 3 is 1 by 9, which is less than 1. X into y is less than 1. So I can directly apply the formula. So this will be equal to tan inverse of x plus y 1 by 3 plus 1 by 3 by 1 minus x into y is 1 by 9. That is equal to tan inverse of, so 2 by 3 by 9 minus 1 is 8 by 9. So 4s are, 3s are, so 3 goes up. That is equal to tan inverse of 3 by 4. So tan inverse of 3 by 4 plus tan inverse of 1 by 7. So now 3 by 4 into 1 by 7. 3 by 4 into 1 by 7 is 3 by 28. This is also less than 1. So again I can apply the direct formula to this addition. So this is equal to tan inverse of 3 by 4 plus 1 by 7 by 1 minus 3 by 4 into 1 by 7. That is equal to tan inverse of, if you do the cross multiplication, 21 plus 4, 25 by 28 divided by 3 by 28. 1 minus 3 by 28 is 25 by 28. So getting cancelled, that is equal to tan inverse 1, which is equal to pi by 4. So I hope you understand the process. I am using the basic formulas of tan inverse x plus tan inverse y. Next, let us go to this question. In this question you are asked to solve tan inverse of 1 plus x by 1 minus x is pi by 4 plus tan inverse x. So what I do is I will apply tan on both sides. So tan of tan inverse of 1 plus x by 1 minus x. Tan and tan inverse gets cancelled. So you get 1 plus x by 1 minus x is equal to tan of pi by 4 plus tan inverse x. Now what is the formula of tan of a plus b? Tan a plus tan b by 1 minus tan a tan b. So tan pi by 4 is 1 plus tan of tan inverse x is x by 1 minus tan pi by 4 is 1. Tan of tan inverse x is x. That means 1 plus x by 1 minus x is equal to 1 plus x by 1 minus x. So, and you're asked to solve this in between 0 to 1. So 1 plus x by 1 minus x is always equal to 1 plus x by 1 minus x between 0 to 1. So the solution is all x from 0 to 1. Property 7 deals with different formulae that we have in inverse trigonometry. So the first and most important formulas relate to tan inverse functions. So tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy if xy is less than 1. So tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy if xy is less than 1. And if xy is greater than 1, if xy is greater than 1, the formula is pi plus tan inverse of x plus y by 1 minus xy. These are two formulas regarding addition of two inverse tan functions. And tan inverse x minus tan inverse y is always equal to tan inverse of x minus y by 1 plus xy. This is for all x comma y. And all these three formulas are valid for positive values of x and y. So whatever formulas that we are dealing with are valid for positive x and y. And if x is negative, I use minus x formulas to get that minus outside, and then once the arguments have become positive, I'll apply these formulas. There are three formulas in total. Tan inverse of x plus tan inverse of y is tan inverse x plus y by 1 minus xy directly if xy is less than 1. Tan inverse x plus y by 1 minus xy plus pi if xy is greater than 1. And tan inverse x minus tan inverse y is equal to tan inverse of x minus y by 1 plus xy if this is valid for all xy which are positive. So you might be wondering why you have different formulas when xy is greater than 1 and xy is less than 1. So let us look at why this happens. Okay, this is not necessary for your JEE Mains. The derivations are important only when you go for advanced exams. So if you are interested, you can see the derivation, otherwise you can skip the derivation. We can understand these two formulas using the quadrant diagrams for tan inverse. First, let us try to derive the basic formula. Tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y by 1 minus xy. And let us see what this condition is. What happens if xy is equal to 1? Because when xy less than 1, you have a formula. When xy greater than 1, you have a formula. So something should be happening at the boundary, right? So let us see what it is. And let us try to see the logic corresponding to this formula. So first, let tan inverse x is equal to some angle alpha and tan inverse y is equal to some angle beta. We have assumed that both x and y are positive. Both x and y are positive. That means alpha is an acute angle, beta is also an acute angle. That is, alpha is in between 0 to pi by 2, beta is also in between 0 to pi by 2. Because the positive number is going inside tan inverse, a positive number is going inside tan inverse. The answer will be in the first quadrant. So this implies x is equal to tan alpha, y is equal to tan beta. Now, what is tan of alpha plus beta? The formula for tan of alpha plus beta is tan alpha plus tan beta, that is x plus y by 1 minus xy. So tan alpha plus beta is x plus y by 1 minus xy. So this implies, now if I apply tan inverse on both sides, tan inverse of tan alpha plus beta is equal to tan inverse of x plus y by 1 minus xy. Now tan inverse of tan. Alpha is in between 0 and pi by 2. Beta is also in between 0 and pi by 2. So what is the range of alpha plus beta? The first angle is some angle between 0 and 90 degrees. The second angle is also in between 0 and 90 degrees. So if you add these two, alpha plus beta can go from 0 to 180 degrees. So on the whole interval 0 to 180, tan inverse and tan do not cancel each other. We have seen that tan inverse of tan cancels each other as long as this angle is in the range of tan inverse, or this angle is in the restricted domain of tan. So what I say is, I'll cancel these two if alpha plus beta is less than pi by 2. That is, from 0 to pi, if alpha plus beta is in between 0 and 90 degrees. So if alpha plus beta is less than pi by 2, that is in between 0 and pi by 2, so you get alpha plus beta is equal to tan inverse of x plus y by 1 minus x. What is alpha and beta? Tan inverse x plus tan inverse y. So tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy if right now alpha plus beta, the sum of these two angles, is less than 90 degrees. Now what happens if alpha plus beta is more than 90 degrees? So if alpha plus beta is more than 90 degrees, directly these two cannot cancel each other. So I need to bring this into the range of tan inverse. So if alpha plus beta, for example, alpha plus beta is equal to 2 pi by 3. So you have tan inverse of tan 2 pi by 3. So the angle is in the second quadrant. So tan is negative. So if you draw the quadrant diagram for tan, plus minus plus minus. So tan 2 pi by 3 is negative. So to get an allied angle, you have to go to the fourth quadrant, right? So first what I do is, I'll do pi minus of 2 pi by 3, I get 60 degrees, and I'll take the negative of that, so that the angle goes into the range of tan inverse. So what I do is, if alpha plus beta is in between pi by 2 and pi, tan inverse of tan alpha plus beta can be written as tan of pi minus of alpha plus beta with a minus sign. That is alpha plus beta minus pi is equal to tan inverse of x plus y by 1 minus x. So now alpha plus beta minus pi. So alpha plus beta, 0 less than alpha plus beta is less than pi, but we are considering alpha plus beta to be in between pi by 2 and pi. So what happens to alpha plus beta minus pi? So this is in between minus pi by 2 and 0, which is in the range of tan inverse. Now these two are getting cancelled. So this implies now alpha plus beta is equal to pi plus tan inverse of whatever it is. So that's what you got the second formula. Now the question is, so how do you decide whether alpha plus beta is less than 90 degrees or greater than 90 degrees? What is the logic which determines whether the sum of these two is greater than 90 or less than 90? So this comes from the identities. So we have already seen that tan inverse of x plus cot inverse of x is equal to pi by 2. And cot inverse of x is nothing but tan inverse of 1 by x. So tan inverse of x plus tan inverse of its reciprocal. So if you have a number here and its reciprocal here, the sum will be exactly equal to pi by 2. That is, if you have x, y is nothing but 1 by x. Yes, according to this, if y is equal to 1 by x, if this number is 1 by this number, the sum will be exactly equal to pi by 2. So that means xy is equal to 1 is the condition which ensures that the sum is equal to pi by 2. Now if xy is less than 1, that means one of the numbers is less than the boundary condition. If x into y is equal to 1, so this number will be exactly equal to pi by 2. The sum will be exactly equal to pi by 2. If this number, if this product is less than 1, that means at least one of the number would have decreased or both numbers would have decreased. And as the number decreases, the corresponding angle decreases. So the sum also decreases. So if xy is less than 1, that simply means that the sum of these two is less than 90 degrees, where this formula works. If x into y is greater than 90 degrees, x into y is greater than 90 degrees. That means xy, tan inverse x plus tan inverse y is greater than 90 degrees. Hence, you get the second formula. So I hope you understand what is happening here. And I encourage you to get the formula for tan inverse x minus tan inverse y also. So I am not doing the derivation for that. You get the exact same type of derivation. And in the negative formula, you won't be having these cases. You'll see that alpha minus beta always belongs to the range of tan inverse. So you don't need to get two different cases. So you need to remember these formulas very clearly. These are the most important formulas of your inverse trigonometry. Now let us look at some examples on this. Next, the formulas corresponding to sine inverse and cos inverse. So sine inverse x plus sine inverse y is equal to sine inverse of x root 1 minus y square plus y root 1 minus x square. The formulas are similar to trigonometric formulas. Sine of a plus b is sine a cos b root of 1 minus sine square plus cos a sine b. So sine inverse of sine a cos b plus cos a sine b. And this direct formula will be valid if x square plus y square is less than or equal to 1. And if x square plus y square is greater than or equal to 1, you get pi minus of this as the answer. Again, this is the condition corresponding to the sum greater than pi by 2 or less than pi by 2. So if this condition is valid, then the sum will be less than pi by 2 in the first quadrant, and the direct formula works. If the sum is greater than pi by 2, this cannot give you greater than pi by 2. So you go to the allied position, pi minus of that. So if the sum of these two is greater than 90 degrees, this number will give you the allied position corresponding to plus. This formula will give you this angle. So from this angle, how do you get this angle? Pi minus theta. So if x square plus y square is less than or equal to 1, direct formula, greater than 1, pi minus of the formula is the answer. Now sine inverse of x minus sine inverse of y. Because this is in between 0 and 90 degrees, y is also in between 0 and 90 degrees. You subtract one from the other. The angles lie between minus 90 degrees and plus 90 degrees, which is in the range of sine inverse. So directly you get the answers for any numbers x and y in the domain of sine inverse x and sine inverse y. Next, if you want cos inverse x plus cos inverse y, if x and y are positive, this angle is in between 0 and 90 degrees. This is also in between 0 and 90 degrees. So where does the sum of these two lie? 0 and 180 degrees. The sum of these two lies between 0 and 180 degrees. And all these angles lie in the range of cos inverse. Hence I can directly use the formula cos inverse of cos A cos B minus sin A sin B. Cos of A plus B is cos A cos B minus sin A sin B. This looks very similar. So I can use the direct formula for cos inverse x plus cos inverse y. Next, if you have cos inverse x minus cos inverse y, this becomes tricky because this is in between 0 and 90 degrees. This is also in between 0 and 90 degrees. You subtract one from the other. You can get any angle in between minus 90 degrees and plus 90 degrees. So when will you get a positive angle? If the first number is more. When will you get a negative angle? The first number is less. Now cos inverse is a decreasing function. So if cos inverse x is more than cos inverse y, if this angle is more than this angle, then this number is in between 0 and 90 degrees. So what is the corresponding condition? Cos inverse x is greater than cos inverse y. Cos inverse is a decreasing function. So if you remove this function, the sign will get reversed. So when x is less than y, this number is in the first quadrant, hence directly the formula can give you the answer. Now if x is greater than y, this is in the negative side. This number is a negative number. This number is a negative number. But when you calculate this formula, it gives the corresponding number in the first quadrant because plus gives you the plus sign. So cos inverse of this will give you the angle in the first quadrant. So if you want the angle in the fourth quadrant, what should you do? Just need to put a minus before it. Minus of this is the answer. So you need to remember these formulas, but the first priority goes to tan inverse formulas, the next priority goes to these formulas. So even if you don't remember these formulas, you can convert the given question into tan inverse and get the answer. I hope you are understanding these formulas. Even if you don't understand the derivations, you need to remember the formulas so that you can solve the problems. So let us try to analyze this question. Sine inverse of 3 by 5 minus sine inverse of 8 by 17 is equal to cos inverse of 84 by 85. We need to prove this. Let us start with the LHS and see whether it is equal to the RHS. So there are two methods. So directly you can deal with sine inverses and use the formula corresponding to sine inverse, or you can convert both of these into tan inverse and go forward. So I'll do it by both the methods. So sine inverse of x minus sine inverse of y is sine inverse of x into root of 1 minus y square minus y into root of 1 minus x square. So for sine inverse x minus sine inverse y, you have only one formula for all cases. That is equal to sine inverse of 3 by 5 into So what is 8 by 17? 1 minus 64 by 289. That is equal to 225 by 289. So if you do the square root of this, you get 15 by 17. So this is 15 by 17 minus 8 by 17 times 1 minus 9 by 25 is 16 by 25, 4 by 5. That is equal to sine inverse of 17 into 5 is 85, 3 into 15 is 45 minus 8 4s are 32 is 13. So sine inverse of 13 by 85. That is equal to cos inverse of what? We know that sine inverse of x is cos inverse of root of 1 minus x square. That is equal to cos inverse of, so root of 1 minus 13 square is 169. 1 minus 169 by 85 square is 7275. So 7275 minus 169 by 7275. So 1 minus 169 by 7275. So if you do the calculations, so you get the numerator as 84 square, the denominator is 85 square. Cos inverse of 84 by 85. So this is what you're asked to prove. Now, let us also try to convert this into tan inverse and get the answer. So you have understood how to convert one inverse trigonometric ratio into another using triangle method. So if you draw the triangle corresponding to the first ratio, so if this is alpha, the opposite side is 3, the hypotenuse is 5. Hence the adjacent side will be equal to 4. If you take the second ratio, the corresponding right angle triangle, like this will be beta, opposite side is 8, the hypotenuse is 17. So if you use the Pythagoras theorem, root of 169, root of 289 minus 64 is 225, root of 225 is 15. Now, sine inverse of 3 by 5 can be written as tan inverse of 3 by 4. And sine inverse of 8 by 17 can be written as tan inverse of 8 by 15. Now, tan inverse x minus tan inverse y is equal to tan inverse of x minus y by 1 plus xy, which is equal to tan inverse of 45 minus 32 is 13 divided by, the LCMs will anyway get cancelled out, 60 plus 24 is 84. So now finally we'll try to convert tan inverse x into cos inverse. So let us again take another right angle triangle, let us be gamma. The opposite side is 13, the adjacent side is 84. So the opposite side by Pythagoras theorem will be equal to 85. So tan inverse of 13 by 84 can be written as cos inverse of 84 by 85. So this is what you're asked to prove. So now let us look at some miscellaneous identities. The first is 2 sine inverse x. 2 sine inverse x is equal to sine inverse of 2x into root of 1 minus x square. Again, the formulas look very close to your trigonometric formulas. So what is the formula for sine 2 theta? 2 sine theta cos theta. 2 sine theta, this is something like cos theta, which is root of 1 minus sine square theta. So 2 sine inverse x is equal to sine inverse of 2x root of 1 minus x square. This formula works as long as x is less than or equal to 1 by root 2. The meaning is, if x is less than or equal to 1 by root 2, this will be less than or equal to pi by 4 into 2 will be less than or equal to pi by 2. In the same condition, if this complete expression is less than pi by 2, the direct formula works. If this expression is greater than pi by 2, so this expression cannot give you that value. And if you draw the quadrant diagram for sine, plus plus minus minus, so if this number is greater than pi by 2, so the LHS will be some value which looks like this. Now what does this formula give you? This formula gives you an allied angle in the range of sine inverse. So what is the allied angle to this? On the positive side, so this is positive. So this should be the answer which is given by this. So the LHS is this angle, the RHS is this angle. So what should you do to make this angle into this angle? Obviously we know that if this is theta, this will be pi minus theta. So suppose this angle is 2 pi by 3. This formula will give you pi by 3. And if you do pi minus pi by 3, you get exactly the same number. Similarly, 2 cos inverse x is equal to cos inverse of 2x square minus 1. And this formula is valid for all positive x between 0 and 1. You can see why. When x is positive, cos inverse x is in between 0 and 90 degrees. So 2 times this is in between 0 and pi, which lies completely in the range of cos inverse. So cos inverse can give you any value in between 0 and pi. So you don't need any extra cases. So 2 cos inverse x is always equal to cos inverse of 2x square minus 1. Again, do you see some similarity with the trigonometric formula? Cos 2 theta is 2 cos square theta minus 1. 2x square minus 1. Next, for all x belongs to positive real numbers, 2 tan inverse x is equal to tan inverse of 2x by 1 minus x square if x is less than or equal to 1, pi plus this if x is greater than 1. Again, if x is less than or equal to 1, tan inverse x is less than or equal to pi by 4, 2 tan inverse x is less than or equal to pi by 2. So if x is less than or equal to 1, this number will be acute angle, hence directly this formula can give you the answer. 2 tan theta by 1 minus tan square theta. Now if x is greater than 1, this number becomes more than pi by 2. So if you draw the quadrant diagram for tan inverse, plus minus plus minus. Now if the LHS is more than pi by 2, this formula will give you an allied angle. So negative side, you have to go to negative side, means this formula will give you this angle. For example, if this total angle is 2 pi by 3, this formula will give you the allied position in the fourth quadrant, is minus pi by 3. So what should you do to minus pi by 3 to make it equal to 2 pi by 3? Pi minus pi by 3. So if you add a pi minus pi by 3 will become 2 pi by 3. That is how you equate the LHS and RHS. So inverse trigonometric identities involve this basic manipulation of the formulas depending on where the angle lies. So I hope you understand all this formula. Next, 2 tan inverse x, as we have seen, is equal to tan inverse of 2x by 1 minus x square if x is less than or equal to 1 and x is positive. So 2 tan inverse x is equal to tan inverse of 2x by 1 minus x square. Now, in this case, this tan inverse can be converted into cos inverse and sine inverse using the triangle method. So, if you use the triangle method, this is alpha, this is 2x, this is 1 minus x square. So, by Pythagoras theorem, if you calculate the hypotenuse, it will turn out to be 1 plus x square. So, tan inverse of 2x by 1 minus x square is equal to sine inverse of 2x by 1 plus x square is equal to cos inverse of 1 minus x square by 1 plus x square. And these straightforward formulas will be valid as long as x is less than or equal to 1. That is, this angle is in between 0 and 90 degrees. Now, if x is greater than 1, the LHS will become more than 90 degrees. That is, from 90 degrees to 180 degrees. So, sine inverse and tan inverse cannot manage these numbers. Cos inverse can manage. So, the formula with respect to cos inverse does not change. Cos inverse can give values between 90 and 180. So, 2 tan inverse x is equal to cos inverse of 1 minus x square by 1 plus x square works. Next, what should you do for sine inverse? So, the LHS. So, this is the quadrant diagram for sine inverse. The LHS is an angle in the second quadrant. So, if you consider sine inverse, what is the angle that this gives? This formula gives you the corresponding angle to this angle within its range. So, what is the corresponding angle for this ray? This ray, because plus has to go to plus. So, 2 tan inverse x, because this lies between 90 and 180, this formula will give you this. So, to bring this to this, so you have to do pi minus of this angle. If this angle is 150 degrees, this will give you 30 degrees. If this is 150 degrees, this will give you 30 degrees. So, how do you make 30 into 150? Pi minus 30. Similarly, if you go to tan inverse, the LHS is the second quadrant. So, what is the quadrant diagram for tan? Plus minus plus minus. So, now tan inverse of 2x by 1 plus x square will give you the corresponding angle to this ray in the range of tan inverse. So, minus has to go to minus. So, this formula will give you this angle. So, what should you add to this to get this ray to this ray? You have to add a 180 degrees. So, this plus pi is the answer. So, I hope you are understanding the manipulations that are involved in deriving the formulas. So, if you understand these simple manipulations, you don't need to remember a lot of formulas. So, the basic formulas, if you remember, you can do the manipulation depending on where the LHS lie. So, this is the beauty of inverse trigonometric functions. So, that's why many students feel it difficult to do these manipulations. So, if you understand the basics of the domain and range of the inverse trigonometric functions and the quadrant diagrams, it is quite simple to derive all these formulas. Personally, I don't remember these formulas. So, I only remember the simple formulas. And whenever you have problems with the range, just need to add or subtract a pi, add a plus or minus sign, so on. Now, let us go and solve a few examples before we conclude this topic. In this question, you're asked to solve cos of 2 sine inverse x is equal to 1 by 9. Let us see how we can do this. So, there is a very simple general method to solve these kind of questions. So, first what we do is, to simplify this, let sine inverse of x is equal to theta. So let us assume the sine inverse of x is equal to theta. This implies x is equal to sine theta. So you need to find x according to this question, means you need to find sine theta. Now, once you substitute this as theta, what does this equation become? Cos 2 theta is equal to 1 by 9. And you need to solve this equation. That means what should you find? You need to find the value of x. That means you need to find the value of sine theta. So if cos 2 theta is equal to 1 by 9, can you find the value of sine theta? I think it is quite simple. So cos 2 theta formula is 1 minus 2 sine square theta is equal to 1 by 9. So 2 sine square theta is equal to 1 minus 1 by 9 is 8 by 9. So 2 and 4. This implies sine theta is equal to plus or minus 2 by 3. This implies the value of x, as we have seen, is plus minus 2 by 3. But you've given specifically that x is greater than 0. Hence, the solution to this is x is equal to plus 2 by 3. In this question, you're asked to solve this equation cos inverse x plus sine inverse of x by 2 is equal to pi by 6. These type of questions, it is always better to send one of the item onto the other side. You have to evenly distribute x's on both sides. First, what I do is sine inverse of x by 2 is equal to pi by 6 minus cos inverse of x. Now, let us apply sine on both sides. So if you apply sine on both sides, sine of sine inverse gets cancelled. So x by 2 is equal to sine of pi by 6 minus cos inverse x. So sine of a minus b is sine a is sine pi by 6 into cos of cos inverse x minus cos pi by 6 into sine of cos inverse x. That is equal to sine 30 degrees is 1 by 2. Cos of cos inverse gets cancelled. So you get x by 2 minus cos pi by 6 is root 3 by 2 times sine of cos inverse x is sine of cos inverse x can be written as sine inverse of root of 1 minus x square. So sine and sine inverse gets cancelled. This implies x by 2 is equal to x by 2 minus root 3 by 2 times root 1 minus x square. So this x by 2 and x by 2 is getting cancelled. This implies root of 1 minus x square is equal to 0. X is equal to plus r minus 1. X is equal to plus r minus 1. So let us see whether the solution satisfies the equation or not. If you put x is equal to 1, you get cos inverse 1 plus sine inverse of 1 by 2. This is 0, this is pi by 6 is equal to pi by 6. So plus 1 is okay. So if you put x is equal to minus 1, cos inverse of minus 1 is pi. And sine inverse of minus half is minus pi by 6. So pi minus pi by 6 is 5 pi by 6, not equal to pi by 6. Hence, minus 1 is not satisfying this equation. So you need to discard this minus 1 solution. So the solution for this is just x is equal to 1. This is the answer to this question. In this question, you are asked to convert cot inverse of root of 1 plus x square minus x into simplest form. So how do we do this? The standard process, we use trigonometric identities. So you have root of 1 plus x square. What should you substitute in the place of x so that root can be removed? So I'll substitute x is equal to tan theta. You can as well substitute x is equal to cot theta also. Okay. So let x is equal to tan theta. So root of 1 plus tan square theta. So root of secant square theta, which is secant theta. So this becomes cot inverse of secant theta minus tan theta. So now let us try to simplify secant theta minus tan theta. So secant theta minus tan theta is nothing but 1 by cos theta minus sin theta by cos theta. Is 1 minus sin theta by cos theta. 1 minus sin theta by cos theta. That is equal to, so what is 1 minus sin theta? I can write this as 1 minus of cos of 90 minus theta by cos theta can be written as sine of 90 minus theta. So why did I convert sine into cos and cos into sine? So that I can apply a standard formulas. So 1 minus cos theta is 2 sine square theta by 2. That is pi by 4 minus theta by 2 divided by sine theta can be written as 2 sine theta by 2 into cos of theta by 2. Is pi by 2 minus theta by 2. 2 and 2 gets cancelled. 1 sine and 1 sine gets cancelled. So this becomes sine of pi by 4 minus theta by 2 by cos of pi by 4 minus theta by 2 is tan of pi by 4 minus theta by 2. And this can also be written as, you have cot inverse outside. So this can be written as cot of pi by 2 minus of this. That becomes pi by 4 plus theta by 2. So effectively, so secant theta minus tan theta can be written as cot of pi by 4 plus theta by 2. Now this cot inverse and this cot gets cancelled. So the answer is pi by 4 plus theta by 2. And what is theta? Tan inverse x. So pi by 4 plus half tan inverse x. This is the simplest form of cot inverse of this. The answer is pi by 4 plus half tan inverse x. In this question, we are asked to find tan inverse of x by y minus tan inverse of x minus y by x plus y. These are the form tan inverse of something minus tan inverse of something. So I will directly use the formula. Tan inverse x minus tan inverse y is equal to tan inverse of x minus y by 1 plus xy. This is the formula. So let us use it here. So this will be equal to tan inverse of x by y minus of x minus y by x plus y, x minus y by 1 plus x by y into x minus y by x plus y. So that is equal to tan inverse of, if you take the LCM here, x into x plus y is x square plus xy minus xy plus y square divided by y times x plus y. So this is the numerator on taking the LCM divided by. So the denominator is y square plus xy plus x square minus xy by y times x plus y is the denominator. Now y times x plus y times x plus y gets cancelled. that is equal to tan inverse of xy minus xy is getting cancelled. Xy minus xy is again getting cancelled. So you get x square plus y square divided by, in the denominator also you have x square plus y square. So these two are getting cancelled. So you get 1. Tan inverse 1 is pi by 4. So tan inverse of x by y plus tan inverse of x minus y by x plus y will always be equal to pi by 4. In this question, you are asked to prove that cot inverse of root 1 plus sin x plus root of 1 minus sin x by root of 1 plus sin x minus root of 1 minus sin x is equal to x by 2. If x is in between 0 and 45 degrees. That is, x is in between 0 and pi by 4. So now, in this question, we'll use the simplification for 1 plus sin x and 1 minus sin x. So 1 plus sin x can be written as, this 1 can be written as sin square x by 2 plus cos square x by 2, and sin x can be written as 2 sin x by 2 cos x by 2. So 1 plus sin x is sin square x by 2 plus cos square x by 2 plus 2 sin x by 2 cos x by 2. This can be written as sin x by 2 plus cos x by 2 whole square. Similarly, 1 minus sin x, by using the similar simplifications, you can write it as sin x by 2 minus cos x by 2 whole square. Sin x by 2 minus cos x by 2 whole square. Now, what is root of 1 plus sin x? So, let us try to simplify what is there inside this. So, root of 1 plus sin x is mod of sin x by 2 plus cos x by 2 plus mod of sin x by 2 minus cos x by 2 divided by mod of sin x by 2 plus cos x by 2 minus mod of sin x by 2 minus cos x by 2. So why am I taking mod? Because square root of x square is not equal to x. It's not always equal to x. So square root of x square is mod x. The square root of 1 plus sin x is square root of sin x by 2 plus cos x by 2 whole square. It is mod of sin x by 2 plus cos x by 2. And similarly, we have the other conditions. Now, x lies between 0 and pi by 4. So, x by 2 lies between 0 and pi by 8, that is 22.5 degrees. So, when x by 2 lies between 0 and 22.5 degrees, both sin x by 2 and cos x by 2 are positive. And sin x by 2 is a smaller number than cos x by 2. From 0 to 45 degrees, you see the graphs of sin x and cos x. Initially, sin x is smaller till pi by 4, and after that sin x will be larger. So, between 0 and 45 degrees, sine of a particular angle is less than cos of that particular angle. So, both are positive. So, the sum is positive. So, mod directly gets off. So, you have sin x by 2 plus cos x by 2 plus sin x by 2 is smaller than cos x by 2. So, sin x by 2 minus cos x by 2, this expression is negative. So, what does mod do? Mod adds an extra minus sign. That is minus of sin x by 2 minus cos x by 2 is cos x by 2 minus sin x by 2 divided by, here also you have sin x by 2 plus cos x by 2 minus of cos x by 2 minus sin x by 2. So minus cos x by 2 plus sin x by 2. So in the numerator, these two are getting cancelled. In the denominator, these two are getting cancelled. So you have 2 cos x by 2 by 2 sin x by 2. 2 is getting cancelled. It is cot of x by 2. So whatever is in the bracket is cot of x by 2. So the given expression is nothing but cot inverse of cot x by 2, where x by 2 lies between 0 and pi by 8, which is in the domain of cot inverse, in the range of cot inverse. So these two are getting cancelled. So you get x by 2 as the answer. Hence, proved. In this question, you are asked to prove that tan inverse of root 1 plus x minus root 1 minus x by root 1 plus x plus root 1 minus x is equal to pi by 4 minus half cos inverse of x. So these types of questions we use trigonometric substitutions. So what I do is let x is equal to cos 2 theta. So why am I using this substitution? Because 1 plus x is inside square root, 1 minus x is inside square root. So you'll have to do an appropriate substitution such that these square roots can be removed. For that, I am using x is equal to cos 2 theta. Now, if x is equal to cos 2 theta, it's given that x is in between minus 1 by root 2 and plus 1 by root 2. It is cos 2 theta is in between minus 1 by root 2 and 1. So for what values of 2 theta will cos be in between minus 1 and plus 1? So if you look at the values of cos, so between 0 and between 0 and pi. So the values look like this is 1, this is minus 1. And cos theta will be minus 1 by root 2 when x is equal to 3 pi by 4. So from 0 to 3 pi by 4, cos theta is greater than minus 1 by root 2. Exactly at 3 pi by 4 it is minus 1 by root 2. At all the values before 3 pi by 4, cos is between minus 1 by root 2 and 1. So if cos 2 theta is in between minus 1 by root 2 to 1, my 2 theta is in between my 3 pi by 4 to 0. It is 0 to 3 pi by 4. It is 0 to 135 degrees. And theta is in between 0 and 3 pi by 8. So let us keep it aside and see where it will be useful later. So let us start with this. So x is cos 2 theta. So root of 1 plus x is root of 1 plus cos 2 theta is equal to root of 2 cos square theta. And root of 1 minus x is root of 2 sine square theta. 1 minus cos 2 theta is 2 sine square theta. 1 plus cos 2 theta is 2 cos square theta. Now, what is root 1 plus x minus root 1 minus x? So this is root 2 times mod cos theta, root 2 times mod sine theta. So the expression becomes tan inverse of root 2 times mod cos theta minus mod sine theta divided by root 2 times mod cos theta plus mod sine theta. So root 2 and root 2 gets cancelled. So theta is in between 0 and 3 pi by 8. So cos theta and sine theta both are positive. So mod directly gets removed. So cos theta minus sine theta by cos theta plus sine theta. So if you divide the whole expression with cos theta. So you get tan inverse of 1 minus tan theta by 1 plus tan theta. That is tan inverse of 1 minus tan theta by 1 plus tan theta is tan pi by 4 minus theta, which is equal to, so tan inverse and tan are getting cancelled because pi by 4 minus theta is within the range of tan inverse. So the answer is pi by 4 minus theta. Now if you back convert it in terms of x, so what is theta? From this 2 theta is equal to cos inverse x. Theta is equal to half cos inverse x. So pi by 4 minus half cos inverse of x is the answer. That is what you are asked to prove. Hence, proved. In this question, you are asked to find the values of tan of 2 tan inverse 1 by 5 and tan of half tan inverse 1 by 5. So how do we do this? So tan of 2 tan inverse 1 by 5. So for questions like this, we have a very general method. We start with let whatever is given here, tan inverse of 1 by 5 is equal to theta. And this implies tan theta is equal to 1 by 5. So if you assume this as theta, so tan inverse 1 by 5, if it is equal to theta, then tan theta has to be equal to 1 by 5. Now, what is the question? You need to find tan of 2 times theta. So the question is to find tan 2 theta. And you know the value of tan theta. So using the value of tan theta, can you find tan 2 theta? Yeah, very simple. So tan 2 theta is 2 tan theta by 1 minus tan square theta. That is equal to 2 times 1 by 5 by 1 minus 1 by 25. That is equal to 2 by 5 divided by 24 by 25. So this gets cancelled 5 times, it's cancelled 12 times, so 5 goes up, so you get 5 by 12 as the answer. So tan of 2 tan inverse 1 by 5 will be equal to 5 by 12. Next, let us go to this question. Tan of half tan inverse 1 by 5. Here also we use exactly the same process. Let tan inverse of 1 by 5 is equal to theta, which implies that tan theta is equal to 1 by 5. Now, according to the question, you need to find tan theta by 2 this time. So, can you find tan theta by 2 in terms of tan theta? So, there is no direct formula for this, but tan theta by 2 can be written as a root of 1 minus cos theta by 1 plus cos theta. Because 1 minus cos theta is 2 sine square theta by 2. This is 2 cos square theta by 2. If you do the square root, you get the root of tan square theta by 2 is tan theta by 2. You have this. Or you can also write it as, so if you use this formula, if you know cos theta and if you know how to find square root, you can find tan theta by 2. But there is a better formula. The better formula is by using rationalization. So what I do is I'll multiply both numerator and denominator with 1 minus cos theta. So what happens to this expression? This expression is root of 1 minus cos theta whole square is 1 minus cos theta. 1 plus cos theta into 1 minus cos theta is 1 minus cos square theta, which is sine square theta. Root of sine square theta is sine theta. So you can use this formula also for tan theta by 2. So this is a easier formula because you don't need to find the square root. But here you need cos theta and sin theta. Now tan inverse 1 by 5 is equal to theta. A positive number is going inside tan. So theta is acute. That is, theta is in the first quadrant. So tan theta is 1 by 5. You can very easily find cos theta and sin theta by triangle method. So tan is 1 by 5. So opposite side 1, adjacent side 5. So this becomes root of 26. And cos theta and sin theta are positive. So you can directly use the positive values. So 1 minus cos theta is 5 by root 26. By sin theta is 1 by root 26. So if you take the LCM, you get root 26 minus 5 as the answer. So root 26 minus 5 is the value of 1 minus cos theta by sin theta or tan theta by 2 or this value. So tan of half tan inverse 1 by 5 is root 26 minus 5. In this question, you're given that tan inverse x plus tan inverse y is equal to pi by 4 and xy is less than 1. And you're asked to find the value of x plus y plus xy. So a very straightforward question. Tan inverse x plus tan inverse y is nothing but tan inverse of x plus y by 1 minus xy. So this is equal to pi by 4. So you apply tan on both sides. So you get x plus y by 1 minus xy is equal to tan pi by 4 is 1. This implies x plus y is equal to 1 minus xy. So if you bring xy onto this side, so x plus y plus xy is equal to 1. So the value of x plus y plus xy is 1. That's the answer. In this question, you're asked to solve the equation 2 tan inverse of cos x is equal to tan inverse of 2 cosecant x. So let us apply standard formula. So 2 tan inverse of something. So 2 tan inverse x is equal to tan inverse of 2x by 1 minus x square. 2 tan theta by 1 minus tan square theta. So 2 tan inverse of cos x. So the LHS can be written as tan inverse of 2 cos x by 1 minus cos square x. So this is equal to tan inverse of 2 cosecant x. So this implies if you compare these two, tan inverse of this is equal to tan inverse of this. So tan inverse and tan inverse gets cancelled because tan inverse is a bijective function. So if these two are equal, then the arguments have to be equal. So 2 cos x by 1 minus cos square x is sin square x is equal to 2 cosecant x is by sin x. So 2 and 2 gets cancelled. 1 sin x gets cancelled. So sin x is in the denominator. So sin x not equal to 0. So this implies cos x by sin x is equal to 1. This implies tan x is equal to 1. So x is equal to n pi plus pi by 4. So corresponding to x is equal to n pi plus pi by 4. So this equation will be valid. So for any x between whose values are n pi plus pi by 4, you can get this equation will be satisfied. In this question, we are asked to prove that cos of tan inverse of sine of cot inverse x is equal to root of 1 plus x square by 2 plus x square. Let us try to systematically prove this. So first, let us try to simplify sine of cot inverse x. So to simplify this, let me convert cot inverse into sine inverse. So if you take triangle method, so if this is theta, cot inverse of x, that is adjacent side by opposite side, is x. From this, the hypotenuse is root of 1 plus x square. So cot inverse of x can be written as sine inverse of 1 by root of 1 plus x square. So sine of sine inverse gets cancelled. So you have root of 1 by 1 plus x square. So this whole thing is effectively 1 by root of 1 plus x square. Now what does LHS become? Cos of tan inverse of 1 by root of 1 plus x square. Now again, let us try to simplify this. So what I do is try to convert this tan inverse into cos inverse. Tan inverse into cos inverse. So again, let us use the triangle method. So if this is alpha now, so tan inverse of 1 by this, that is opposite side is 1, the adjacent side is root of 1 plus x square. Now what does the hypotenuse become? Root of 1 square plus 1 plus x square, that is 2 plus x square. So tan inverse of opposite side by adjacent side will be equal to cos inverse of adjacent side by hypotenuse, root of 1 plus x square by 2 plus x square. So cos and cos inverse gets cancelled, that is equal to root of 1 plus x square by 2 plus x square. This is what you are asked to prove. In this question, you are asked to simplify tan inverse of a cos x minus b sin x by b cos x plus a sin x. So let us try to use the formula tan inverse of x plus y by 1 minus xy is equal to tan inverse x plus tan inverse y, or tan inverse of x minus y by 1 plus xy is equal to tan inverse x minus tan inverse y. So we'll try to use either one of these formulas, whichever is convenient here. So you need to have something plus something by 1 minus something into something, or something minus something by 1 plus this. So let us see what we can do with the given expression. So tan inverse of, what I try to do is, I'll divide the numerator and denominator by b cos x. I'll try to divide both the numerator and denominator by b cos x. So what happens if I divide numerator and denominator by b cos x? So a cos x by b cos x minus b sin x by b cos x divided by b cos x by b cos x plus a sin x by b cos x. So cos x and cos x gets cancelled, b and b gets cancelled, cos x and cos x gets cancelled, b and b gets cancelled, nothing gets cancelled here. That is equal to tan inverse of a by b minus sin x by cos x is tan x by 1 plus a by b times tan x. So if you take this as an entity and this as another entity, so this is of the form tan inverse of something minus something by 1 plus something into something. Something minus something by 1 plus something into something. So that is equal to tan inverse of A by B minus tan inverse of tan x. This is tan inverse of something minus tan inverse of the other. That is equal to tan inverse of A by B. Tan inverse of tan x is x minus x. So this will be the required simplification of this. So this finally gets simplified to tan inverse of A by B minus x. In this question, we are asked to simplify tan inverse of root of 1 minus cos x by 1 plus cos x. So this is a very straightforward expression. 1 minus cos x is a 2 sine square x by 2. 1 plus cos x is 2 cos square x by 2. So if you divide one with the other, 1 minus cos x by 1 plus cos x is 2 sine square x by 2 by 2 cos square x by 2. It is tan square of x by 2. So root of 1 minus cos x by 1 plus cos x is root of this is equal to root of tan square x by 2, which is equal to mod of tan x by 2. Mod of tan x by 2. And x is in between 0 to pi. So x by 2 is in between 0 and pi by 2. So tan x by 2 is positive. So mod tan x by 2 becomes tan x by 2. So what does this expression become? Tan inverse of tan x by 2. X by 2 is an acute angle which lies in the range of tan inverse. Hence tan inverse and tan gets cancelled each other. The answer is x by 2. Thank you.